Hello everyone and welcome to today's session on AWS Terraform by Intellipaat. Terraform is a tool for building, changing and versioning infrastructure safely and efficiently. Terraform can help with multi-cloud by having one workflow for all clouds. The infrastructure Terraform manages can be hosted on public clouds like Amazon Web Services, Microsoft Azure and Google Cloud Platform, or on-prem in private clouds such as VMware vSphere, OpenStack, or CloudStack. Terraform treats infrastructure as code (IAC), so you never have to worry about your infrastructure drifting away from its desired configuration. In this session, we will learn all about AWS Terraform, so without further wait, let's start this session.
But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
So first of all, what we are going to talk, this is the first chapter, which is related to the infrastructure as a code. So in the what happened, like Terraform is introduced in 2014. So I'll be talking about the brief about how Terraform introduced and why it got introduced, what was the requirement to get it into the picture. So if you talk about infrastructure as a code, from the previous one, what was happening, like people were building from the tools itself, they are writing a command, and after that they're building that system, or they're building an image which could be a Docker image, which could be a small OpenStack system or infrastructure which is building multiple virtual machine on the top of that, or it could be a virtual box. So there what we have to do, we have to go into that particular tool and then start creating virtual machines and start creating load balancers, start creating firewalls. So that was a lot of manual work. And if you talk about small companies, there is not an issue, they can build it again and again. If you talk about big applications, big giant companies, those are basically leading the world with the IT industry, and they are working on a lot of applications. They are dealing with the artificial intelligence, they are dealing with the medical intelligence, healthcare departments, they are dealing with a lot of different components of the industry. So that what was the reason to build this infrastructure as a code, so that you can monitor what are the changes you are doing in your infrastructure. Basically, infrastructure is a set of your deployments. In, like, if you say a virtual machine, that is an infra. If you say a load balancer, that is also an infrastructure. Okay, and where your code is going to run and your application will be seen to end user. So this is what the basic definition. And infrastructure is written in the code because you are doing it from the portal, or you are doing it from the multiple tools. So those are not basically a standard way. If you have the backups, you want to track what are the changes you are doing daily. If you want to go back to your changes, that where you can write the codes, and that is where you write some commands, and that's your infrastructure is built automatically. You just need to design the code. It takes, like, suppose you wanted to build a big giant application that is connected to the application gateway, that is somewhere you have to install traffic managers, and that is connected to the AKS cluster. Okay, so that what are the requirements you will be having? First, you have to create an infra. That's where you have to create a jump server. After that, you have to create a few like application gateway. You have to create backend connections with the health checks. You have to create everything. You have to do it via the manual way. And along with that, AKS cluster. So AKS will going to help you about the microservices. So that microservices are building on that. So you need to look every time you wanted to do some changes with your infrastructure, you need to look into those infrastructure, go onto the portal and do every changes. And eventually you don't know what is already there. So that infrastructure as a code will going to give you a brief what is already there with an outputs, like, or what are the public IPs, what are the application running on, what are the load right now we have. So such kind of things we're getting to know about with the Terraform. And so first, this is the brief. We'll look into the complete stack of DevOps, how DevOps is built and why DevOps is so preferred. Like every big company or every small company, startups, eventually they are going on DevOps and they are preferring to use Terraform with the every cloud service provider. And after that, we'll understand multi-cloud benefits. That's what you already guys know, that like Terraform can support to GCP, AWS or Azure. So that we are going to use that. And after that, we'll look into the architecture, how it communicate to your Azure infrastructure, how it communicate to your AWS infrastructure, how it communicate to the GCP. So that we are going to look. And after that, the communication of internal working. So what Terraform is talking to where and how Terraform internal processes are working. And after that, we wrap up this session. So, okay, guys, so we'll be starting the session now. So basically, Terraform was built released in 2014, and it is built by HashiCorp. HashiCorp is an organization which is building multiple tools, and they have Packer, they have Vagrant, and they have multiple tools, but this is the tool which is very famous, which is used by a lot of cloud service providers and the partner companies as well as the users and users to build their infrastructure. This tool is written in Go language. It's a Go language, and basically why it is so popular because of this term only. Like, this is going to support 125 providers, and if you talk about Azure, it's a one provider. That means the cloud service providers, which is your like where you can deploy your codes. It's Oracle, it's your VirtualBox, it's your GCP, it's your AWS. So basically we have big giants, AWS, GCP, and the Azure, but this tool is going to support a lot of, or more than 125 of the service providers in the market. And like basically this is what it's major clouds they are supporting. They are supporting the cloud, they are supporting network infrastructure designing, they are supporting the network, they are supporting virtual systems designing, and along with that databases and the other community changes, they are supporting everything. Okay, so in that perspective, that is why it is so popular, that is why it is so needed in terms of the tool requirement. And then we'll be seeing why it is got introduced in terms of your changes in terms of your infrastructure only. And what I'll be just giving you a brief on that, like where we are going to use the Terraform, and then we'll see some theory as well. So basically, you see, this is the Forbes list of 2021. And HashiCorp, this is the organization which built cloud, and these are the top cloud companies. Basically, we have Strip, we have Databricks, Canva, and the fourth number is HashiCorp. That's why it is very, very popular, and they are getting a lot of fundings, they are getting a lot of connections, and it is basically built in California, US, and they are doing very great job in terms of infrastructure automation. So this tool is basically not doing anything more than the infrastructure provisioning. They are just focusing on the your creation of your infrastructure. If you're creating a VM, you know how to create a VM, and that VM is going to be created by the Terraform only. You are not doing the internal configurations with that. Like if you wanted to have Apache, if you wanted to have, like we have created a Linux VM. Let's take an example. You have created a Linux VM. In that, till now you are planning to create. You are in a planning phase. You wanted to have 10 VMs, and those 10 VMs will going to lead to a particular single application or multiple applications. And those basically those VMs should have some tools installed automatically. Okay. So first of all, what you are going to do, you are going to create those 10 VMs manually. Okay. And that is going to take a lot of time. After that, you go into those VMs and manually you started installing Apache, apt-get Apache, apt-get Apache. You did all these things, and it's an Ubuntu system basically. And after that, you start configuring your application, particular tools you have installed. So like that is a kind of an hectic job, and that is not considered in the manual jobs are not considered in DevOps. And DevOps is basically to do the automation, to resolve the issues between dev team and the operations team. So that's why they have come with this tool, so that you create your automated tool, or if you wanted to change anything, you destroy that particular tool, or you destroy that particular infrastructure, you rebuild that particular infrastructure after you start creating that. Okay, so infrastructure is the resource on which applications runs on, and that what we have already discussed. And infrastructure as a code comes with few particular modules, and that's where we are going to look forward. So basically defining and provisioning. Look, you have to define that you wanted to use Ubuntu system, and then you have to choose, this is the VM, like Ubuntu 18 point some version I wanted to use, or 20 point some version I wanted to use. 18.04 you have choose, so that you have defined your goal. So this is your goal for the infrastructure. After that, you going to provision that particular ISO image. You got that ISO image and you started creating that. Okay, now after that, there are a lot of tasks with that. You have to manage those infrastructure, like you have to update all those things, apt-get update. You have to create multiple application changes. You wanted to push your code to that particular VM, or you wanted to have management of the code. So that infrastructure as a code will going to help you in that. You have to have the infrastructure as a code if you wanted to get all these details in your organization with the particular project. And then descriptive model. So that descriptive model we are going to cover in next slide. I have given a full detail on this model. And versioning, basically, suppose you are using 18.04, and along with that some app version is there. You wanted to upgrade your versions along with your, what you can say, along with your OS version as well. Okay, what happened if you talk about old scenarios which were used in the before the 2014, so that what was happening, they was used to restrict themselves with the same version. They are not changing with the versions frequently. They are just using the versions. Maybe if that OS which previously was used, that got some what you can say, some vulnerabilities got introduced to the market, and they have some hackers are going to like basically attack on those VMs. So what we have to do, we have to upgrade those VMs. What is the upgradations? Basically upgradations so that you can improve the GUI, you can improve like your security, you can like neglect your whatever vulnerabilities was exposed to the internet, so that you can improve the code, you can secure your project which you are creating for the particular application. Okay, and along with that, this infrastructure as a code is very readable. It's kind of like what you are doing, you are just writing a simple what in terms of which you can do, you are writing a simple paragraph, or you are just writing a small like a speech or kind of that thing. So that speech is going to deliver to the system, and system will convert automatically. So that is very easy. Like if you are not aware of programming, that is not an issue. If you are exposed to the programming, you will see like why this code or infrastructure as a code is so easy, and why we are doing in Java, why we are doing that complexity in every programming language we are dealing with. But this is very easy. This is the easiest language, I can say that. So I also don't have the programming background, but I'll be basically doing that because I just learned in short time period, and that is very readable, that is very understandable. And along with that, there are a lot of supports available online, and itself with the Terraform website, they have a lot of support in terms of if you wanted to create a virtual machine, if you wanted to create log analytics workspace, if you wanted to create any other system in Azure. So they have already everything with predefined demos. Like they have already picturized that this is the code you have to use, and what you have to do, you just need to modify that code as per the name. Like I wanted to create a virtual machine, so I'll be going into the Terraform portal, and from there itself I took the code, and that code I just need to modify the name. I wanted to create Intellipaat VM, and after that another functionality what I need to give, username and the password, I need to define those, and after that I need to define my VM name. Like I wanted to create a Windows 2019, a Windows Server 2019, or else I wanted to have Windows 10. So that is all up to me. So I have to define those. So they have given the format, everything is they have given. So that we'll be talking. So any on-prem or cloud infrastructure with the programming interface, so that is all needed. So basically, like if you are dealing with OpenStack, you cannot have a particular programming interface right now. You have to build your own programming interface if you are dealing with the OpenStack. All along with that, if you talk about any other cloud service provider or on-premises virtualization tools, if you talk about VMware, if you talk about VirtualBox, they are also supporting the Terraform. So you just need to install Terraform, and you can configure your servers. If you have the on-premises data center, you can configure that as well, or you can configure your machines in cloud as well. So it is basically a DevOps practice that is way important in terms of this line is very important. If you want to take a note, you can take this line as a note, but these are the basic notes. For after the session, you can recap what are the things you have learned. So these two lines, you can have a note on that, and I'll be sharing this PDF. So when to use infrastructure as a code? If you wanted to have a lot of machines, thousands of machines you wanted to create, you are already exposed with the AKS, and you know microservices are basically auto scale system, auto scaling in and out, they do automatically, and they have create a lot of pods and nodes and everything, so that you guys don't need to look into those services and the traffic coming in and out. Ingress will handle that, right? Similarly, infrastructure as a code, where we have to deal with a lot of, like suppose let's take an example, we have to deal with the 100 virtual machines which is built on Linux. Okay, I have to create those virtual machines. I have to go on particular system, and I have to configure that again and again and again. I have to repeat the same process. But in infrastructure as a code, I just write that, I just build a code, and I repeat that code for the particular time period. And like in that code, I've given like I wanted to have similar machine or similar infrastructure with the particular naming conventions, where I'll be using the for loop, and that we're going to learn along with that. So in that for loop, I defined that I wanted to take this virtual machine to tell like this process should repeat till like 10 or 100 number, so that I'll be having different names of my virtual machines with the particular coordinates. Along with that, the different resources are created in a given timestamp. That's fine. Your infrastructure is rented from many different providers. And like that's all we know. Like we can use GCP, we can use AWS, we can use Azure in a single file. I can create multiple if I wanted to create 2 virtual machines in Azure and 1 load balancer in AWS and any other service or Power BI service in Azure again, so that what I can do, I just need to write those services. I just need to write, and the code is already prepared, and I can fetch the provider, like which provider I'll be going to use. Providers are basically Azure itself. If you say Azure is a provider and AWS is the provider, like which is going to provide you the systems to configure infrastructure for yourself. Okay, so you from whom you are getting your servers, from whom you are getting your services, and you are configuring everything in terms of your infrastructure as a code. You need to make regular adjustment to your infrastructure. So in this term, what you can say, I have 100 employees in my company. I'm not taking an example of virtual machines. I'm just taking an example of real world. I have 100 people in the team. Right now, you have 100 people in the team, and that team is basically designing some applications. And what happened? You have somehow your client got very impressed with that particular tool which you are creating, and what they said, let's increase the load, or let's create a similar application and use it for the another project. A similar application, that means like basically you can say, if you are in medical, healthcare departments have similar applications for the multiple work. They have wanted to use that application, so what they do, they wanted to separate the infrastructure as well. So you have to build again 50 approx, like 100 you already have, and now you are increasing the load and you wanted to hire 50 more people for the same infrastructure, but with the different project. Okay, so what you have to do, you have to go there and again install the 50 systems and look for the installations and everything. But now right now you have an option. You already created the script with the infrastructure as a code, and that is going to provide you the capability in terms of just creating an infrastructure. In 2 or 3 hours, your 50 systems are ready for another employees which are going to join your company to build that application. Like that application is basically based on the Windows 10, Windows Server 2014 or 2019, that is building on that only, or 2022. So latest versions they are using. So what you can do, you just write that code. I wanted to have 50 systems of this particular version, or this particular changes I wanted to have. And along with that, you can attach your PowerShell scripts, or you can attach your shell scripts. That we'll going to look into that. PowerShell scripts, what this PowerShell script is going to do, if I wanted to have Visual Studio installed in that particular system, if I wanted to have particular tools which are internal teams I wanted to install, or Zoom call I wanted to install, so such things, that is going to make your systems ready for the future coming up people, those are going to join that company. So you just need to create these. You have to create the username and the password for them, and they are getting all the information in one go. They just open, you eventually you don't need to open the laptop. They have the virtual machines or VDI machines. From there you have done the configuration, and they are going to access those via the VPNs or RDP systems. So that is the very special connections, so that it will going to save you a lot of cost. You don't need to hire 10 network engineers. You don't need to hire like 50 people just to, like, they have to spend or 3 or 4 days to provision their laptops to make them work for the project. So that is not the case will be happening for the people, and they are just going to save a lot of time. And along with that, now there is another condition comes in, and those are the 100 people which are going to work, which were working in the same environment. Now what you did, you just replace those 20 people in that 100 number. You just replace those into the another project, like project number 2, where we have 50 people. So you have to maintain the documentation. What you have to do, you have to change according to that project number second. So what changes you did in their systems, there are certain changes which you have to do in the particular system. Okay, so those changes should be like after that you switched and you wanted to again have those particular project number 2 people, those you have switched to the project number 2, that should be working with the project number 1 again. So 10 people you move back in that. So that's why you have to have what is current infrastructure, what is what changes we did previously, like similar to the Git. Like if you are maintaining your history, commit history, your commit changes, and every structure you are maintaining, similarly Terraform do that. Whatever changes, you are increasing the RAM, you are increasing the changes, you are doing scale in, scale out, what are the public IP was previously, what is right now public IP is, you can get those inputs as well. Understood? Okay, so you want to optimize collaboration between administrator and the developers. So that was a basic issue was with what you can say with the without the DevOps. When DevOps was not introduced, this was the issue. Like people were just doing blame game. Basically, if developers are working on their systems, they have different kind of versions installed, and like operation team have different version of tools installed. They are doing in like suppose they are doing some testing, developers are doing some testing on their system, they just create the code and they send it to the operation team, and those operation teams are just checking the code with the different versions of the systems which they are using, or with the different infrastructure, right? So that what was the issue coming in? So they said with the different versions, it's not working. Your code is not working, but developer says it's working with me fine. And you should look with the strategies which you are using. So that's where the time is getting consumed, and that's where, like, if you spend half an hour or 1 hour in IT industry, 50 people are just discussing, which is not a point of discussion. So it is going to cost a lot to the company. So what DevOps is going to do? DevOps is going to build that simple infrastructure with the same version, whatever developers are using, whatever admins are using, whatever operations teams are using, so that exactly the same infrastructure with the requirements, with the versions, with the application changes which we have made, so that they can do the testing, they can do the dev prod and like UAT environments. You must be aware of that as well. So those are the things which taking in place, and those changing according to the requirements of market and according to the requirements of saving the cost and the increasing the security, increasing the value of an engineer which is going to build an application. So that is going to help a lot in terms of everything, in terms of your application building to the releasing to the final clients. So what is happening till now with the infrastructure as a code? Basically, you have your infrastructure and you wanted to automate. So what you can say, those are building the infrastructure. You can say they are DevOps engineers, or they are cloud engineers, or they can be a developer. Okay, because developers are already dealing with a lot of complex programming languages, and they are easy to understand this infrastructure as a code. They can understand in 10 days or 15 days. They can just learn Terraform in 2, 3, 4 days. That is not an issue for them. So developers are already exposed with the programming. So if they wanted to build an infrastructure, they can do it by themselves, or we have DevOps team which is going to build infrastructure and maintain the infrastructure. Okay, if there is a requirement to maintain that infrastructure or dealing with the changes again and again, so that's where DevOps comes into the existence, and that's what we guys are doing. And basically, if you are writing that code, which is known as infrastructure automation, after that you create those code and you push to the some repository, you push to API servers, or you push to the registry, which is a Terraform registry. You push to the remote system similar to the GitHub, or you can push to the GitHub as well. Okay, so that is where you create the infrastructure and then you do the testing. That testing phase, we are going to look into that as well today only. So we are going to see what are the testing tactics you can use to validate this code is written, which is written is with very fine, or it is need to be changed in terms of anything. And along with that, similar git we have to use version control, so that I can find that what are the changes I have done previously, and if I made a mistake, how I can replicate, or how I can move back, or how I can revert to the similar infrastructure. So dealing with the applications, dealing with the code, that is a good job, but dealing with the infrastructure is a very tough job, because if you're dealing with the infra, if you have made a mistake, that is going to cost you a lot, because if your infrastructure is down, your applications are down, your developers are not doing anything, and your users are not using applications. So we have to be careful before building an applications. We have to take a validations in every changes which we are going to do. And if you're dealing with infrastructure, you have to have the expertise before going into the infrastructure changes that you wanted to do. You can build that is an easy job. Management is the very tough job in terms of building a Terraform architecture and all. So maintaining, that means you have to upgrade the systems you wanted to deploy. You have already built an infrastructure manually. Okay, you wanted to create 10 VMs, and 5 VMs you have done manually. You are not going to delete those, right? You don't want to delete those. Okay, what you have to do, you just neglect those VMs, and you're not dealing with that. You are just create a similar kind of namings of your VMs, and that which is going to build again for the again 5 VMs which is required for your application. Okay, so this is the process. push and pull is working similar to the Git. The code is pushed and pulled to the repositories and repository along with the if you have in place CI/CD pipelines, if you have added your directly to the infrastructure, if you are building with the these are the basically your what I can say machines which is going to build your applications and which is going to do the deployments directly to the system. So there is a one API which is basically in terms of Azure. I have created a diagram so that I'll be showing you guys. But in that, how Azure is going to communicate to the Terraform infra, that is very easy job, and that we are going to look. Okay, so this is, I hope this is clear. So if you are dealing with the infrastructure in cloud, so this is the communication via the API only. So API will going to talk to the cloud like, please, this is the communication, and you have to create this with the particular agenda, like this is what we wanted to have in place, and you have to create this. Okay, so let me show you a diagram which is very important in terms of, you must be aware of that, but okay, so let me have a diagram which is going to talk about how Azure works, and I'll be adding that in terms of how you can add that. Okay, so this is an API. This is the backend of Azure. You are aware of Azure, that is good. But let's take an example. Here, your API is here, and that's where your, what I can say, that's where your Terraform is going to in place here. Okay, so this is the Terraform, and this Terraform is going to communicate to the API of Azure, and API of Azure will tell that orchestrator. There is a tool which is installed in the data center itself. I'm talking about the data centers or backend of Azure, backend of whatever written in Azure. So they have a lot of data centers in multiple regions. So that orchestrator will going to communicate to the Fabric controller, and Fabric controller is installed to the every server or every rack or every system which is available in the cloud. So that will going to ask what you wanted to have, what are the requirements you have, and it will decide where it going to be built. Like if it's required to have an availability set or availability zone, or it is required to have 2 VMs in place with the VMSS. So that is going to be decision maker is Fabric controller, but this the API which is going to give the code or detailing to the orchestrator, and orchestrator will tell to which Fabric controller will going to build this application. Okay, so that is the basic thing. Like a Fabric controller is on the particular VM or particular servers. This server is having a single Fabric controller. It's kind of a virtual box which is going to help you to build the applications. Similar on-premises virtual box or VMware workstations are helping. Similarly, Fabric controller is managed by the data center engineers in the Azure or in the cloud itself. So they are managing that. We are not exposed to that. We are just having the API, or which is called our Azure portal or ARM templates. From there itself, we are building that. And along with that, we have another tool is called Terraform. So that is just a brief. And that's where like here you can add that diagram, you can add here. Okay, this automation is going to talk to the API server, the API to the particular orchestrator, and that orchestrator will going to communicate to the Fabric controller in terms of Azure cloud only. Okay, so that is where deployment is coming. That is where deployment is happening. And before that, we have taken care of these components. Automation we did automation via the Terraform. We manage the configurations via the Terraform. Then we know how to manage those versions. Like if you have changed daily, if you are changing frequently with your machines or with your infrastructure, you can do it via the easiest way of the version controlling. And the automated testing where you have to define your testing purpose, like if my configurations are correct or not. So those testings, we are going to look into that. So how you can look or validate your code which you have written before running your application code. Because if you run your code and if you have made any changes or any mistake you are doing, so you can rewash that code again and again, so that it will going to help you a lot in terms of your infra. If that infra is built, if you wanted to change anything, you have to destroy that. That is basically immutable. So if you are aware of this word immutable, that is going to coming in the next slides, that will going to help you in terms of building again and again infrastructure. Okay, and that's clear to the infrastructure as a code. And then there is a lot more complex diagram in terms of Terraform, so that we're going to look. Okay, so basically what are the benefits with this? Speed. Basically you can create 50 VMs in terms of that example we are taking. You can create 50 VMs in just a small time period, and that is going to solve a lot of problems. That is going to solve a lot of issues with the team members. And then consistency. That's where, like, consistency, if you wanted to change the code, you can change the code with your VMs. You wanted to destroy the VMs, you wanted to use your VMs with the efficient way, that you can do. Accountability. you know who created that. You know basically who is the responsible people in the team, who's going to build that infra. And along with that, you know which system is used by whom. That is where you create username and the passwords for the particular users. And then you can, like, if you have been using Azure, what you have to do, if you are creating a username and the password, or you are creating an active directory, from there itself you are adding a new member in the team. So what you have to do, you have to go into the users in the active directory or default directory which you have. First you add that person in that particular active directory, and then you assign that resource group the particular project is running in. So you go in IAM access control. In that access control, you give a contributor access or admin access. Basically admin is not preferred. Along as per the requirement of that particular person, you have to assign that. Okay, so like suppose right now in your system you have 10 members, those having admin access, or they can provide the similar access to other members. So you don't have the accountability. You can see the logs, but you still not have the accountability to change the code. Like suppose somebody changed the access or somebody changed or deleted anything, you can look into the logs. But in terms of infrastructure as a code, that is basically designed by the code. If you are going to delete anything, that is not applicable. If you are using an infrastructure, you are going to lock your systems, everything you are going to lock, so that if person is dealing with the particular machines or particular code, they are still not capable to delete those. Or like suppose there is any mishappening happened, so you don't wanted to get into the fight with the client. So that is the basically reason.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So that you can build a same infrastructure in within 10 minutes or 20 minutes. If you have destroyed anything, if you have dealt with anything, you know this person did that, and you have to ask them to build that again. Your DevOps engineers are going to build the same infrastructure, whatever it is. Like it is going to have 50 VMs, 200 VMs, it is going to build again if there is an mishappening happened, any disaster comes into the organization. So that you have the script written in your code, in form of code. You just run that script with the few commands, and then it is running your infrastructure again. With the what you can do, you can have in the same servers. If you wanted to change your servers, you can do. Along with that, increase efficiency. There are two terms of efficiency. One is the developers are only focused on the work, or building the codes or building the applications. They are not just dealing with the operation teams or with such kind of issues which is related to the versions, which is related to the application infrastructure. Like they are using different code, or they are using different kind of application, or further testing that code. So that is going to be very enhanced. Another point is, if you have suppose right now that application is taking, if in the dev environment that application is, you have assigned 100 GB of RAM for that particular application, and you divide it to the developers, and 100 GB of RAM is going to build up for the particular dev environment, and along with that developers have their own systems. Okay, so you are paying for that 100 GB RAM, and along with that 1000 GB of storage. Okay, so in that after some time you think that I'm using 50% of that particular resource. What you can do, you can lower down to 60% of your, like right now your consumption is 50%, so you cannot make it to till 50%. You have to have some buffer. So what you do, you make it to the 60% or the 70%, and that 30% of your spaces of your 30 GB of RAM, you can save that much cost in the cloud. Okay, cloud is basically working on the pay as you go model, so you can save your cost in that terms. And that is going to be built in just within a second. You just click 30 or 40 or 70, that is all you have to do, and that is going to build that infrastructure as per your requirements. So there are two ways. Okay, so in that terms, basically infrastructure with the imperative way, and there is another term which is called declarative way. Okay, so in imperative way, this is if you are going with the Terraform certification, and this is the terms which is going to ask a lot in terms of your examination, and there will be a one question. I'll be just focusing on the Terraform along with the certification, so you guys can achieve a goal. Good certification you can have. Along with that, Azure knowledge you guys can have for your projects which you are planning to work on. Okay, so this imperative will be basically based on this question, how. Okay, but your declarative is based on the what. Okay, so you understand with this terminology, basically how, like somebody says come to my house. Okay, or somebody says join the call. So what you are going to do, you go in your room, or in terms of your basically call, you go into the room, you open the laptop, you type the password and everything, and then after that you open the browser and you open the Teams, or you click on the link and then join the call. Okay, so you are explaining this thing to the client, and is client is going to happy with that? No, because basically they are just focusing on the final result. Okay, they are just not looking for how you do that. So in terms of shell scripting, what you have to do, PowerShell and shell scripting, so you have to write a small command, define a specific command that need to be executed in the proper order to the end with the desired conclusion. Like I have to leave the house. If I wanted to, like I asked to my friend, please come to my house. So he leave from the house with the given time period, then get in the car, drive straight onto this road, and then for the 3 kilometers and turn on right and take the right and for 5 blocks, and after he reached to my house. So basically I just don't want to hear this story, whatever happened to him, how he came, how we are talking. We are in the professional world, we have to focus on the final goal. That's where the requirements are fulfilling. Clients will never going to listen how you did that. They are just satisfying if you have done it or not. That is the actual goal. So that is the focus on the actual provisioning process. It is basically focus on that process. If you're building any code with the Azure portal, portal.azure.com, if you're doing that, that is the imperative process where you have to type your VM name, you have to type every detail, small detail. After that, it will create a JSON template. 2 templates it will create, and after that it will going to create your particular settings and configurations. Okay, so that way is not preferred way now, and we have to just focus on the what. So this declarative state which is used in the Terraform, so we are not dealing with anything like developers are basically dealing with that process or imperative process. We are going to write the codes. We are just writing the codes. We know this infrastructure or this code is going to build whatever things are going to be built. We know what is the end result. Okay, so if I am going to build a particular VM, I just write the code and I know what are the end goals, and I can use that code again and again with the multiple applications. But if you are writing a particular VM in Azure, portal.azure.com, from like basically infrastructure of the portal, you are writing like you define the VM, you define everything, and you are doing one by one. In AWS, you can provision multiple infrastructure instances basically, but in Azure, you have to repeat that process again and again. If you have observed that, if you have created a VM, if you have created any tool, after the creation, after the provisioning state, they ask you again, do you wanted to create it again, or you wanted to go to the resource? There are 2 columns after the deployment is done. Okay, so that's where the this is the process, and in this process, you have to look for the declarative states. You have to just look, like I called my friend and ask him, just come to my house, and he reached to my house. If you're going in a wedding, you are not going to tell them to the bride and groom that I came from this, I did this. You have just to shown up into the wedding, and that's the ultimate goal. So that is only related to your requirements. So client is just dealing with the requirements. They are paying you, they are paying us, so we are just dealing with that particular requirements. If we are building an application, we have to deal with the end goal, that is the desired goal. For that desired goal, if you have taken 5 hours, if you have taken 10 hours, that is not a matter. Okay, you're building the codes, that's all, that's what you are doing. Okay, so the focus on let's look into the definition. Focus on the desired end state of the deployment and rely on the interpretation engine to create and configure the actual process. What is our interpretation engine? This is our Terraform. This is a desired end state of the deployment. This deployment is basically, if you have worked with the Kubernetes, you have to create deployments with the particular pods, like how much pods you wanted to have, how much replica you wanted to create. So that you have to define. Okay. Similarly, in Azure or in Terraform, you have to have an interpretation engine that is going to deal with the your actual resources which are going to be created. Okay, if you have aware of why I'm taking so many examples in terms of other tools. If you have used Docker engine, your interpretation engine in terms of Docker desktop or Docker engine, or what you can say daemon, so that is going to build your multiple containers in terms of your services. That's clear to you guys. So there are certain advantages that we have already seen. We know now, like it is going to be help us to repeat repeat that process again for the dev environment, for the prod, and we don't need to write that code again and again. We just need to define the name, like this is the name of this code, and this is the name of this virtual machine, this is the name of this virtual network, and that is taken care by the infrastructure as a code or the Terraform. And again, the version control we have discussed, speed is very well, like in terms of if you are using your home network, if you are using this is not the basically bandwidth, this is the speed of building your infrastructure. So why I took the reference of bandwidths, basically if you are using your home network or if you are using your mobile network, there is a lot of difference. Okay, in my home network I have 150 mbps speed. In my phone I have 5 mbps of speed. So similarly in Azure, if you are building an application via the portal, it is going to take a lot of time. If you are going to make 50 VMs or 20 VMs, it is going to take a lot of time or money in terms of if you are saying companies are paying hourly basis or the monthly basis, or they have to look into that, like how much productive their team members are. So that's where the speed matters. Along with that, the validation, this is the term which is going to, like, if this term is not available in infrastructure as a code, this should not be exist in the real world. If you can't validate the code, because this is going to make a lot of issues. If you can't validate your code before creating a infrastructure, you cannot use infrastructure as a code, or the Terraform you cannot use. So that's why we have the validation tool, which is itself Terraform Validate. This is the tool, or this is the command which is going to look for the code whatever you have written. This is the particular term which I've seen, Terraform Valid. This is the command which you are going to look into that. And again, the documentations, and very good documentation from the Terraform, from the Azure. They have a lot of good documentation in terms of how you can create your infrastructure and provisioning your infrastructure. And reuse, again, the repeatability and reuse are basically, if you wanted to use that code into the different code, into the different product, or what I can say that into the different project, that code you just need to copy that code, need to change the name of your services which you wanted to use, and then again create that. So basically we are going to look with the DevOps, what DevOps is basically is. And like you see, you just look into this diagram why Terraform is mostly used. And in terms of Terraform, you just need to write a single file. In that, you wanted to create cognitive services with the Microsoft, you wanted to create AI ML services with the Google Cloud, and you wanted to have microservices with the Kubernetes, and you wanted to create some kind of service, you can say EC2 instances you wanted to create in Amazon. So that what you guys do, you just write a script in a single file or a single folder. You have written some scripts, you have given the validations, you have given the username, passwords, you have given the command lines. So those are required to get into these portals. You have to validate yourself, like you have to give the subscription IDs, you have to give the secret IDs, such kind of information you have to share with Terraform, and Terraform will take care of everything, whatever you wanted to create. This is going to support the Oracle as well. So that already talked. DevOps is basically based on 3 words: communication, collaboration, the integration. Communication between these two teams, so that we are lying in between these two teams. We are different people, and we are just making some people to be more productive. Basically DevOps is just basically they are making people to be more productive. They are making people to do their jobs, and operation team are doing the testing, development teams are doing that work that is relevant to them, but we are just focusing on the process. DevOps is a culture. Basically it's not basically a tool or anything, or not the people. They have the culture which is connecting the communication, which is making a collaboration between these two teams and along with the DevOps team. And then integration of the tools. Integration is coming with the technical terms. The tools which they are using, we are going to build those tools. You don't need to look. Development team should not be looking into the tool building or installing an application and anything in terms of the requirements they are having. So they just say that please go and just create this infrastructure for us, and we are going to build that. We are exception in terms of everything. We have a lot of tools. We are very advanced. If you say DevOps team is very advanced in terms of tool use, if any tools comes into the existence in terms of microservices, in terms of Kubernetes or Terraform, DevOps, Chef, Puppet, a lot of tools are available. So those tools are basically adopted by the DevOps team. They learn it, and then after that they use it in terms of saving their team members time. Basically we are not doing work for ourselves, we are doing for our team members, and other can work peacefully. So this is the what a general terms in terms of DevOps. And this is a software lifecycle. What are the tools available? And this is you see why DevOps is DevOps itself. because this is an never ending life cycle. Never ending. We have to code again, we have to build again, we have to retest it, then release it, then deploy it, then operate it, and then monitor, then again plan it. Then if you have completed your monitoring, you have to plan it again. In terms of like we wanted to change something, let's plan it and let's create a code, let's push the code to the Git, Jira, and Confluence. We have these tools and you must be using from one of them. Basically Git is mandatory to push the code, and Jira, Confluence, or you can say Azure DevOps, Azure boards itself, where you are going to look for the ticket system. These are the ticket systems, and you must be using Azure boards. So where work items you create and you attach with the particular work item to the particular branch name, and if you push their code, you look into that, and after that you close that work item as per if your requirements are done. And if you push the code, that should be built. Okay, so Maven and SBT and Gradle and MS Build, there are a lot of tools available in the market. Those are going to build your application. Maven is basically focused on the Java applications. If you push your code, developers are pushing their code and infrastructure team is pushing their own code, and developers are pushing the code which is coming to the particular, what I can say, to the remote repository, Azure DevOps or Azure Repos, basically Azure Repos or the GitHub or Bitbucket. From there itself, it is going to the build, and you have designed the CI pipeline. This is the phase where you have to design your CI pipeline. Okay, so your pipeline, which is reside in Azure DevOps, there you have built your Maven code, and you have created POM pom.xml, which is basically going to download the dependency from the internet. This is also a very good tool, and this is basically doing another automation in the CI. Like this is an evolution, and Git is also known as an evolution, and Terraform is also an evolution. This is Kubernetes, which is very, very amazing tool, and that's you guys already using. And these are the tool which is changing the way people was working, which is changing the way how testings and applications are building on, because this is a fast phase generation, and we have to move with the changes of the code. We have to move with the releases. We have to give results to the client as fast as we can. And let's move into the, like, I hope you got what I was trying to deliver. So you have to be adaptive in terms of DevOps engineers. So this is the job we have to be advanced. If our team is should be flexible with the infrastructure provisioning, with the configuration provisioning, or every kind of tools which are there they are dealing with. So microservices and all. Selenium is basically testing your code. I've talked about these. Selenium is basically integrated. You can integrate with Azure DevOps itself. You can use, and JUnit is also going to help you a lot with the testing of your code. So these codes will going to test by the these in the CI pipe. You can integrate with the CI pipeline itself. You can test your code and do the, you can, if you are using a YAML pipeline, you can add the code and you can change as per your requirements. And release pipeline, basically Jenkins is basically going to build your code, and a similar build and deploy the code. And this is basically not doing anything, just collecting your jobs and doing with the service principles. You have to create, like delivering your application to the end users. So that is all tools are connected with that Jenkins, or you can say Azure release and Azure pipelines, which are CI and CD pipelines. And Nagios is basically monitoring your code. Prometheus is also a tool which is going to monitoring, you already know Azure Monitor. We have Azure Monitor in terms of what you can say in, if you are dealing with Azure, we have Azure Monitor. Let me speak about what are the tools with the Azure. We have Seleniums, and we have to use third-party tools. Right now, we have in release, we have Azure pipelines, Azure DevOps itself. In the monitor, we have Azure Monitor, we have Azure Insights, we have alert systems, we have like log analytics workspace to the monitoring the services and everything. Network Watcher we have in terms of looking into the network operations which are going correctly or not. And then we have Kubernetes and Ansible and the Chef. So Kubernetes is not just operating the code. They are also using the deployments, but this is a very good tool to manage everything. Okay, so Ansible can be integrated with this Kubernetes. You can use Ansible and the Kubernetes all together, and where you can create your containers, and that's where your applications are going to run. And Chef is we are going to look into the Chef, so I'll keeping this aside. And AWS, you are guys already aware of the AWS and Azure. So this is the life cycle. And why plan is half and half into this, because plan is going again after the monitoring. You see there is some vulnerability in the code. We have to change the code, and developers are changing with that code. They are dealing with that issues. So what they do, they plan it out again and they build the code. Or we wanted to create multiple machines again with the requirements comes in. So we plan it out and we build that code again. So this is a never ending process and going again and again. Okay. So this is the architecture. which is basically you guys can take a screenshot or I can share you. So we have already talked about what are the things available. So first of all, like you start with here, you build your code, you go with the code review, you do the testing, then you create a continuous integration and the delivery, and then delivery will be taken care by the Jenkins. After that, Jenkins will communicate to these tools like what you want. You have to Terraform is here. I wanted to create this. Terraform is basically going to look into these components, deployment, configurations, and orchestrations. Like basically, Terraform is not going to do the Kubernetes jobs, but they are telling that Kubernetes is I need the Kubernetes in my picture. Okay, so that's where we are going to decide what Terraform is going to do. And similar job Ansible do, but Ansible is basically a mutable. So that we are going to look into the next slides why we are not preferring Ansible, but it is not exactly to the Terraform. Terraform is basically way advanced than in terms of creation of your infrastructure. So that's why we are just restricting Terraform to the creation of infrastructure, not configuring those infrastructure. So yeah, and let's move on to this. We have focused on this diagram only that we have already talked. Like Terraform is basically going to do those jobs, and you see you're talking about there is a tool which is going to help to do every kind of jobs. So we have Azure DevOps. Azure DevOps basically using 5 tools: artifacts, Azure boards, release, and the build, and basically the repos. Okay, the 5 tools are being used by the Azure boards, but you also integrate these tools. You cannot push your code without using it. You cannot build the code without using Maven. You have to integrate it into your pipelines. That's where, by the way, you don't need these 3 tools: Bamboo, Jenkins, and Travis CI. You don't need to have those in place. You just directly use or create your CI pipelines and integrate with your Azure repos, and that Azure repos is connected to your local Git, and that is you push the code, and that is built by your requirements as per the changes you are doing. And along with that, you have to integrate the Kubernetes or AKS cluster with the pipelines where you are going to build your code. Orchestrations are going to be happening. Okay. Along with that, it could be on monitoring purpose as well. We can consider this diagram till top because we have Azure Monitor. We have a lot of tools available in terms of monitoring that we already talked about, and you can add these third-party tools. Nagios you can add, Prometheus you can integrate. Okay, Prometheus and Grafana, you must be aware of those. So do those we can integrate. Okay, so that's where. Let's see the spectrum as of today. Still, we haven't touched Terraform. What is Terraform? We just know the infrastructure as a code. We haven't touched the Terraform, and we already passed 1 hour. But why I did this? Because you must be a fan of Terraform if you are working with Terraform. Okay, so that is what I'm making you guys right now. So why it is so popular, why it is so used, why it is helping a lot in terms of if you are a DevOps engineer, why it is solving a lot of issues in terms of coming in terms of your workarounds which are doing. Workspaces are there. You have multiple environments. Right now you have dev environment you created. Suppose you have created dev environment. Now you understood that dev is created now. Okay, now you wanted to move into the UAT environment or the prod environment. That is the prod environment where you wanted to have 2 deployment slots, where one is going to look into the your final application, and another one is on hold, like green blue deployments you wanted to have. So that's where you can use Terraform, and you can save your time, you can save your approaches, you can save the configuration time, you can just deploy it directly. Okay, so basically Packer is an infrastructure templating code. Basically, if you create an ISO image, if you are creating a VM image, that you can do with the Packer. Okay, so just taking a small brief, we are going to see in the next 3 or 4 slides. Vagrant is not in use right now, like it is in use, but it is not popular. But these 3 tools are built by HashiCorp. This Vagrant, Packer, and the Terraform. But most of the tools are most of the requirements are fulfilled by the Terraform. Okay, Cloud Init, and then CF Engine, Salt Stack, Ansible, Puppet, and Chef. We are going to look into the brief, but these are going to do the manage infrastructure, install applications, and one-time configurations. Why Terraform is like just covering the infrastructure part, but it is still in the position to top all these tools. Okay, but Ansible is equivalent to the Terraform in terms of configuration management. Puppet and Chef have some kind of issues in terms of agents and all, so that we are going to look into that. That's why Ansible is also leading in configuration management, and Terraform is leading infrastructure management. I hope you can find 2 terms which I'm saying. First is configuration management, which is handled by the Ansible. Another one is the what I can say, the infrastructure management that is handled by the Terraform. If you are creating a 10 GB 8 GB of RAM and 10 GB of storage or 100 GB of storage, that is taken care by Terraform. Or if you are installing Visual Studio, or if you are installing browser in the particular machine, that is taken care by the Ansible. So that is the configurations inside the VM. Like after the Terraform is work is completed by the Terraform, you can look for the Ansible. Okay, so that's again a particular part. So previously, what was people was doing, they are just looking into the sudo apt get update, sudo apt install. These are the things, and you must be doing that in terms of if you are not using Ansible or Terraform. So these are the tools which are available, or these are the things you have to do manually. Again, configuration management, these are the tools. Server templating, packet Docker and Vagrant we have. Server provisioning, Terraform we have. ARM, you must be exposed to this terminology. Okay, Packer, basically I'm not going to be taking 1 minute in particular slide. I'll be moving very fast because these are not the basically I'm building a phase so you guys can understand why we are using Terraform and what are the requirements or other tools are available. You just, what you have to do after this session or after these sessions completes, you guys have to review each and every slide again. I'll be giving you my 100%. So this Packer is basically a tool which is going to create your ISO image. Just take an example. You are going to create an ISO image, or you are going to create a small image. So that is a builder tool that is not going to run the application. That is just you are going to by the end of this Packer tool, you are going to get the particular image only. You're not going to get any provisioning or running VMs or any kind of changes. Like first stage is to get the VM, another stage is to provisioning, which is done by the Terraform. Another stage is to install tools which is required for this particular Visual Studio wanted to install. So that thing is a post processor, and that is what our like Ansible is doing. This is Terraform is doing, and this Packer is doing. But this is handled by the cloud. Okay, that's where like we don't need to look into that. We have the AKS, and AKS is behind that. If they are using Packer or if they are using any other tool to build those images, that is we don't need to look into that. So that's where we don't need to use this tool, and that is not required at all. But you must be aware what are the tools available in the market to do what. Okay, and that is also built by the same company. Those build the Terraform, they have built this tool, and they majorly focus on the building and provisioning of the environment. So this tool is going to build. First step is going to done by this tool. And if you wanted to modify, like suppose you have Windows 10 ISO image, okay, and now you wanted to change something and you wanted to add it to that image, you can do it with the pattern. Okay, Vagrant, and this is not a tool to use now. This is basically going to like majorly like they are using similar to the VirtualBox. They are just holding your VM images, and you just need to call a VirtualBox. We have the Vagrant image, Vagrant file we have to write, so that whatever Packer have done, we have to make that file into the existence. Like VMs are coming into the existence. So still that is not also required. Cloud is taking care of that. So that's why Vagrant is also not in use. And they are in use, but it is basically what I can say, not in much purposeful. Like these are already available. Cloud is basically, that is the requirement of the cloud. If these tools are available, you can do it for your on-premises environment. You can use these tools, but we already have cloud. We have Azure, we have AWS, we have GCP. So that's where we guys can basically save our time and just to spin up our applications as per the requirements. Understood? This is the tool which is we are going to learn. And this tool is basically going to use HashiCorp configuration language, HCL, to describe the infrastructure you need. And I will be giving you a small brief on this. You will be getting a mastery on this language, which is very like, see, whatever right now you are seeing, this is written similar. You have to type into the code. Just you have to taken care of a key and value like ID and password. You have to look into that. And along with that, you are good to go to create infrastructures. A lot of infrastructure you can create. So be confident on that. We have providers. Like what are the modules I will be covering? Providers, provisioners, modules. These are not the modules, the normal modules. These are the inside the Terraform. There are some modules, and then plan phase, and then apply phase, and then the destroy phase. That we are going to look into that. Best suited for the managing infrastructure resources. So this is the tool which is best suited. Cloud in it is basically what you can say, the hosting your applications and creating your applications in terms of cloud. So basically you can integrate this with the Terraform as well, and you can review again on this part as well. Ansible we have already talked about, and this is going to be taken care of your configuration management. If you wanted to have any particular tools installed in the particular VMs, like thousands of VMs you wanted to create, and you wanted to have those tools installed on all those thousands machines, what you do, you create a particular playbook. This is the playbook, and you just play that book. Basically, it is kind of a teacher is coming into the class, and they have the book, and they are giving a chapter. Whatever right now we are doing a playbook work. Like I am just playing this book, which is a PPT, and you guys are grabbing those knowledge which I whatever I'm saying and whatever you guys are seeing on. Okay. Similarly, playbook is going to talk to the VMs and to tell them, you guys need to learn this, or you guys need to install this tool in your environment because your user required that. Okay, so that is where the requirements are fulfilling with these tools. And again, this is an agentless tool. Basically, you don't need to create multiple agent. Like in Azure, if you are building a tool, you have to have Microsoft hosted agents or as well as self-hosted agents. Right now, you guys must be using Microsoft hosted agents, or the majorly you have created a VMSS in your environment, and that's where basically you are building a CI or CD pipelines. So that is not the case with the Ansible. You don't need to have the agents. Chef is basically, it is not an agentless. You have to create multiple agents similar to the you are doing it for the CI and CD. CI CD we cannot do with that. Like if you don't have agent where you are going to run your application. Similarly, but in Ansible, what happened? Ansible is going to use that particular system to run the agent work. Whatever agent is going to do, they are going to connect with that machine where they have to install, and they are going to talk to them only directly. And in this, Chef used for the configuration management, exact same recipe, whatever Ansible is doing, similar they are going to do here. And Puppet is also the similar way, but it is using a client server model, and server is the Puppet, and client is basically we have to install some tools into the client or every machine. Like suppose I have 100 machines and I have to install this Puppet into those machines. What is the sense of that? I have to do those manual work. That's why Ansible is where just you need to give the ID password. Like I have the public IP of this VM. I wanted to install Visual Studio on that, and I have the public IP of and that machine, or I have to do the SSH of that. Okay, by the SSH to that machine, I'll be going to connect to that particular agent, or what you can say what we call it user, where we are going to build our worker users we needed to that. Okay, and SaaS stack, it is for designing to the scaling of your applications. You wanted to scale up your applications. You wanted to download tools into those applications, and the similar applications you wanted to create again, like dev environment, prod environment, and the like another environment which is UAT environment. So similar tools you wanted to install in that, but it is also using client and server model. So that is not preferred. If you have agent-led less tool, why you're going to use the agent, and where you have to work all those machines. That's why you are saving your time to not to work on those machines, but you in these tools you have to work on those machines.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And this is again, you can take a screenshot or you can look again into this diagram, but this is basically a tool, or this is where like you have to do, like if I'm working with a client and we have to do some POC with that particular client. What we have to do, we have to discuss what is basically the requirements for that client. Like if this tool is going to be suitable for their requirements, you have to look into these. Like basically this is an imperative and declarative, you know the terminologies. That's why this is the final diagram of my 1 hour of discussion, whatever we did. This is the final diagram which is going to give you the knowledge in terms of your solution architect designing. Like if you wanted to create an architecture, you have to decide which tool you are going to prefer and why you are going to prefer. Because you are just not saying that I want to use a Terraform, but client will say why you wanted to use Terraform, because we have Ansible, we can use Ansible, we can use Chef. But if you know what are the benefits of Terraform is offering, you can tell to your client. Basically, they are not technical, or they are just aware of these tools, so you have to tell them as well. And along with that, we are using these languages, manifest file return languages. Puppet is using DSL and ERB, And chef, you have to know the Ruby language. That is where like you have to learn first Ruby language, then you can use that. YAML are basically general language now in terms of building Kubernetes manifest files, and in terms of deployment files, and similar Ansible, you have to write the YAML scripting. Salt Stack is basically also using this YAML pipeline, YAML code basically language. And Terraform, like they are basically, you know the YAML, you are already know the HCL language as well. So which is HashiCorp configuration language, which is very easy, and we are going to look into that as well. And now we are going to understand mutable and immutable are what are these things, so that we are going to look into the next slides. That's perfect. So we are introducing Terraform now. We have understood Terraform, but we haven't started Terraform yet. We haven't seen which version we are going to use. We haven't seen how we are going to install the Terraform. So that's where we are going to use now. Basically, Terraform is going to solve time to build, human error, tracking changes, application environment, rebuilding environment, and managing multiple resources. You guys just read it out, and this is what we are going to do again and again every day. And if you are using Terraform, these are the things every day you have to do it. Like you are dealing with the time to build, you are going to save your time. If you have made any mistake, that is also validated by the Terraform. That's where beautifully Terraform will tell you that's where you have made a mistake. This is the particular line. Kind of a compiler. If you are compiling your code, they are going to look into that particular code. What are the mistakes and syntax errors are there? And if you have made some mistake, you just revalidate and then move further. And then tracking changes every day. Suppose there are two DevOps engineers which are building Terraform infrastructure. So like there could be multiple engineers, those are working with the Terraform, because the requirements are changing a lot with a particular tool. If you're talking about Amazon.com, like basically they are using Terraform, but they are not using Azure. That's why, like, let's take an example of Microsoft.com. This is a website which is offering a lot of tools, lot of offerings in terms of they have their own tools. They have Visual Studio we can download. We can download Windows 11. We can purchase multiple what I can say, the laptop we can purchase from their website itself. They have similar tools as well. So those things need to be taken care by multiple teams. So if you are looking for the career page in the Microsoft, career.microsoft.com, that is taken care by the different infrastructure. That is what APIs are. Like career.microsoft.com, that particular API will be managed by the different infrastructure team. So that's where the changes should be tracked. Everything we should know, what tech manager should be aware, what are the changes we have done today, and how much occupancy of the infrastructure is running, so that we can save our cost. Okay, replicating environment. And suppose you are going to create a similar application for the Microsoft, or you are going to create an e-commerce application, and again you are launching another product with another website, or you are running a training company and you wanted to create another training course for the particular domain. So what you are going to do, you are going to replicate that environment. You are going to host a lot of videos in that training company. So that's like right now we are using Zoom. That's where they have multiple similar environment. Like if I'm using Zoom, you are using Zoom, like everybody is using Zoom. What they are doing, they are basically having a video call, or like the screen sharing call, so that like they need the similar environment. So that's why Zoom team, what they are doing, they are just replicating environment for the another team, another subscriptions which are purchased from them. So they are doing that, rebuilding that, and that's where you change some changes in your environment, and then you rebuild it. And then again, managing multiple resources. Like you have to create resource group. In that resource group, you have virtual networks, you have subnets. If you have virtual network, after that you can create subnets. That is the dependency. You can't create a subnet directly without having a virtual network. Similarly, if you wanted to create a virtual machine, you have to have the virtual network, you have to have the public IP. You can like not a mandatory public IP, but at least the private IP or bastion host, right? So that is mandatory to have in terms of your requirements. So this is what topics daily we are looking into that. Today we are going to look into the cloud provider. This is basically we have to look how we can design the code in terms of AWS. I will be going to cover everything like AWS, Azure, or you're dealing with the Oracle Cloud. I can tell you where you can learn from that, but the labs will be based on Azure only, and I'll need to figure out the AWS as well. But basically, you can look like which tool is required for what. And then again, resource, those are not basic normal resources. These are different resources. In terms of Terraform, we have resource which we are going to create, and then configuration files, and then some of the variables which are going to write as per the requirements of changing the requirements. And that's where variables are going to help you to reuse your code in this cloud provider, which is going to help you to which cloud provider you wanted to use. Resource are what you are going to create. Configurations files are basically you write your instructions in that, and variables are basically making your code to be reusable. Suppose you wanted to create multiple VMs. What you do? You define the variables, you write the code, and then again change the variable name. Like suppose right now VM name is like Intellipaat RG. The resource group name is Intellipaat RG. Now after that you wanted to create another resource group which is Terraform RG. You just change the variable name of the resource group, and that's where your configurations are going on. Then state files, basically that is the file which is going to if any disaster comes in, if any issues comes into your Terraform, this state file is basically going to, like suppose your infrastructure destroyed. So what happened? This state file is the latest updated file. Whatever configurations are there, whatever infrastructure, like 100 VMs are there, this is written in JSON. Basically this file is written in JSON, and this is basically secured file. You cannot basically write, you cannot look into the Visual Studio right directly. You have to look with the particular code base. So that's we are going to figure out how we are going to look into the state files, and those state files are going to be stored in some remote applications. Like you have to create a storage account, and suppose like this is a central repository for your state files. And like I have 100 VMs, I have created 101 VM. I have created another VM, one more VM, and I have updated my state file. And somewhere my team members are also not aware of that. So what I have to do, I have to make it like 3 Terraform developers are working on this particular application. And now I have created like what you can say 101 virtual machine. Another that should be updated to those as well. So this is a central state file .tf.state file, which is an extension, and that is going to help you a lot to share the information. Whatever you have done, the changes, that is going to be stored on storage accounts. We are going to connect to the storage accounts, and we are going to do the coding with that. And then data sources and modules, workspaces, and the provisioner, security, Terraform enterprise, and best practices that we are going to look forward with along with the sessions. And like suppose you have created a resource group manually and you wanted to create 2 VMs in that resource group. What you are going to do? You are going to use data source, and that data source you tell to Terraform that we have already this resource created, and you just not need to create this again. Okay, just rewrite or just execute whatever I have written below the commands. You just need to create that thing only. Okay, and basically these are the cloud service providers, and these are the tools which I've already talked. ARM template, Azure Resource Manager, we know. So these are the tools, and they have their own tools. Why Terraform is preferred? Because you cannot work, like if you have CloudFormation in place, you cannot work with Azure. If you have created a template for the AWS, you cannot use this template to the Azure. But in Terraform, you can use all these single template to build everything. So Terraform is here. Okay. And now we have terraform.stat. Like basically, if you are writing a Terraform file, which is coming with the TF extensions only. Okay. This is the TF extension. And this is like, if you see any Java file, you have that jar file. If you have created a var file that coming with the extension of var, or you can say .exe file, which is coming with the extension .exe, like that is an executable file. You get to know that is an executable file. Okay. Similarly, if you wanted to understand which is a Terraform file, you get to know with the TF. Okay. And this is a TF var. TF vars, basically this is going to store your multiple environment data. Basically this is changing the extension, but still it is going to work for the Terraform only. And this is the Terraform.state, which is not manually going to be created. This is auto updated automatically. Okay, you are not going to look into this. Just this is going to be updated to some cloud environment. Like in Azure, we wanted to store this automatically. Some developer did that. And like again, I came back to the work and I see that there are certain changes. So what I do, I have to take the input from the Terraform.state file, like whatever changes we have done in the Terraform environment, that should be fetched to my local environment. After that, I build the code and I'll push the code to this infrastructure building. And after that, I'll push that code again to the Terraform.state, like where storage account is created. And then this is where I'll going to define my, like I wanted to have this VM, this is the subnet, this is the virtual network, and this is the requirement I wanted to create. And the provider.tf, basically you have to define, I wanted to create on AWS, I wanted to create on Windows system, and this is a Google system where I wanted to create. So providers are basically, this could be the separate file, or you can combine provider.tf or terraform.tf, same files you can combine. And please guys, Terraform is a game of files always. The written, whatever you are writing, that is going to be created. Okay, so you just need to remember all these. You can take a screenshot on this diagram as well, because this is the exact name you have to use. Like you are going to create a virtual machine, you have to choose an image. Similarly, you have to create the this tf var file, .tf file, .instant file you have to create a virtual machine. Understood? Any doubt till now? We know Terraform is written in Go language. We know it can change, it can build, and it can look into the versioning of the infrastructure. This is basically what I was referring to. Configurations files, which is written in HashiCorp configuration language, or you can use a JSON format as well. So whatever return you are writing, that extension should be changed .tf .json. Okay, Terraform provider .tf will be there. Always TF will be there again, but what you have to do .tf .json. Okay, so you can write this. So that's how a JSON file will be looking into that. But we don't prefer to use that, but we have to use this performance way of creating this infrastructure. Because why we use TF? Because this TF is going to work with every kind of infrastructure. This is going to work with the VMware. This is going to work along Oracle and other service providers. But JSON file, there could be some complexities we have to change, and we have to. This basically a JSON file is slightly hectic job in terms of writing a code in terms of Terraform files or HCL language. So that's slightly we are going to cover. And we know this is ability to manage standard cloud vendors and custom in-house solutions. That is all we know. Like we have cloud vendors or custom in-house solutions that we wanted to have. What you can say on-premises environment. That's where the VMware comes into the existence, and the virtual boxes. Configuration files used to define required resources. So TF file, this is what is going to define your requirements, which is required for you to create your application. Terraform generated execution plan to reach the desired state. So this is the plan. So Terraform will going to create a plan. We are not talking in detail right now, but in upcoming slides, we are going to talk about that. Responsible for the creation of the server and associated services. That is basically creating or your whatever services are associated with the resource group, that is responsible by the Terraform only. And manage low level and high level components. That's what we are going to look for the slides. So basically Terraform is going to handle self-service clusters. Basically multiple developers are here, and I wanted to have this environment, I wanted to have this environment, I wanted to have this environment. Developers are building those, and they can use that particular code. They can use reusable module. That module, it's a terminology which we are going to look forward in the upcoming sessions. And basically this is what the staging area and the production area and the development area. This is what workspaces are. That those two topics which I haven't touched in that slide, basically development, staging, and the production. These are the three different separate environments where development teams are working on, staging teams are working on, the production, which is the end user goal, like where end users are going to look into that. So I have changed something in this particular development infrastructure that should be pushed to this another workspace. This is what we call workspaces. Okay. And this is modules. Like if you created a module, you can use it again and again and again. If I have to spin up a virtual machine, I just need to use that module, and that module will ask me the name of the virtual machine and the requirement of the virtual machine you wanted to create, and it will automatically spin up. Automation will be there. Okay. So you guys must have created Kubernetes clusters, right? Let's have a discussion on that. So you guys have created AKS clusters, and basically you have used those AKS clusters, but your team says, I wanted to create that AKS clusters again. That AKS cluster again. AKS have multiple components. In the masternode, we have API servers, we have controllers, we have schedulers, we have etcd, basically the key value pair storage that we have. So now you have to spin up your cluster, and you don't have any chance that you are going to create it for the staging environment or the production environment. What you have to do, you have to go again into the portal. You have to do the same process what you were already did, but you don't have that kind of script that I have created. This script, let's create multiple thousands of environment you can create. That's where our project.main.tf file comes in, our workspaces. That's what I was referring. And in the next slide, we are going to look for the example which I was talking. So like I wanted to have a service, I wanted to have the pod autoscaler, I wanted to create replication controller or pods, multiple pods, I can do it via the Terraform. I can create PV, PVC, storage, everything I can do it via the Terraform. So that's where you have to just write, like, I wanted to create this, and that example we are going to look into the AKS lab which we are going to do. So basically we know you can have a single file. You just write AWS provider. I wanted to create AWS provider. I wanted to have Azure or Google Cloud provider that I can use. And then that particular provider will call to the AWS. Like they will authenticate your subscription first. Like first you have created a main file. Let's take a very simple way. You have created a main file. And now in that main file, there are three things are going to be happening. Three clusters. For another is like GKE cluster, AKS cluster, and the EKS cluster. GKE basically the what you can say Google Kubernetes engine. So that is where you are going to create. So three clusters are you are going to create. But in the single file you write that. So in the single file you write your requirements. You use AWS provider code. I'll be giving you those naming conventions, like how you have to write those codes. In HCL language, we have three words you have to remember. You have to remember AWS. This is the provider name itself. You have to remember Azure RM. That is the particular provider name itself. And then that provider itself will go into AWS name will automatically call to the API calls. Like it will iterate the calls and it will talk to the AWS environment, or it will talk to the Azure environment. It will talk to the GCP environment, and it will provision the environment automatically. So which is basically Terraform is a cloud agnostic. Basically it is going to build your infrastructure with the multiple environments with the same single file. And that this is the reason why Terraform is used. You guys are able to understand what is happening right now. So mutable environment is basically if you have an application running into the picture, what happened? Application version is here. Application changes are you are doing. What you are doing, whatever changes you did, you are deploying into the same version of systems. But in this is not the case with the Terraform. Terraform is immutable. You are not going to change. Like I have created this VM, 3 VMs I have created. If I wanted to upgrade to the another VM, I have to destroy these particular running VMs, and another I have to create another VMs. Like provision new infrastructure with the version 2. New VMs are going to be created, like similar environment, similar things are going to be created, but this will be destroyed. Version 2 will be introduced automatically. Why it is needed? Like you must be thinking like why we should delete that environment we have already created. Why should we prefer to delete that? Okay, so there is a reason to have the immutable system infrastructure because this. Okay, so immutable are basically just rebooting the system. Like whatever we are doing, we are not like basically I have my phone. I have to update any application in iOS. I go onto the app store. I just updated that application. I'm not going to update my operating system, or I'm not going to purchase a new iPhone, right? That is the thing. But in this world of Terraform, you have to not to purchase the iPhone again, but to reinstall that OS which is installed, OS version, whatever OS version we have installed. Okay, so this is basically helping to eradicate the issues. Suppose you have updated app version 1.0 and now you have upgraded to the app version v1 1.1, and now in that version there are certain dependencies which are not going to work with the OS v101. Okay, 0.0. Basically this one will not going to work with particular version. This is not compatible. What you are going to do, like it will be facing a lot of issues. Your users are not getting the application up and running. So that what you do in the given time period, you have the deployment slots running. What you do, you just create that, you run the CI/CD pipeline, you destroy that environment, and itself in 10 minutes your application is already running with the previous version. Right now the users are not aware that there is some updates are going from previous changes to the next phase. They don't know about that, and right now you destroyed that environment, and in given time period you updated your OS, you updated your versions, you updated your application code, you updated everything, and now there is no compatibility issues with that particular OS. Like you cannot run some applications in Windows Server 2009, but you can run in 2012. So that's where you have to change the OS. Suppose versions got changes and you wanted to upgrade your application. We are talking about the data center type of applications. We are not talking about the end users. We are just talking about we are sitting in data center, and we have to think like that only. Like I have my application which is going to deploy it on some version of the application, Ubuntu version, or like I can say the Windows Server 2012. but that is my need. I have to update to the 2019 because my application is going to work with the 2019 only. That is the compatibility. So that's where you destroy this environment and you create it in the given time period. In a small time period, it will be spinning up the environment again with the Terraform. And now your application, there's no compatibility issues, there is no versioning errors, there is no upgradations errors. You just using that and then you are going with the peaceful way. Basically, we are just learning about mutable and immutable system. Okay, so in that process, what is happening right now, I have some OS which is Windows Server 2012. Okay, and that OS and that app is basically version 1.1 right now, 1.0. Okay, what happened in certain period of time, we did some changes in the application, and you must be aware that there are certain dependencies. Like suppose the Java versions should be same, and you have to install different Java version as per the upgradations comes. Why we do the upgradations? Because of some upgrades are only based on the features. First is feature, like enhanced features, requirements are closed. And along with that, there is one more thing, which is vulnerabilities or bugs clearance. Okay, so that's why new version. Why Windows are launched again and again? Because of these two features, these two things, like bug fixes and the features are changed by the like I'm using Windows 11 right now. I have upgraded. Why I have upgraded? Because of the requirements got changed. I have to use some tools here. Some tools were not working into the Windows 10, so I have to upgrade to my operating system. But in this mutable environment, that is not possible. You have to offline your application. You have to make it offline. After that, you do the upgradation manually. Because you're not using the automation here, you have to go into the data center room and you have to install this. On in Terraform, what you do in server 2000, you have to upgrade to the server 2019. What you do, you just write in the Terraform file, and that is immutable. Basically, you have created this, and like that, what it will going to do, it will going to delete this. Like whatever offline work you were doing, it will doing it from the server, and it will delete that. It will upgrade your system. I'm not talking about the upgrade and update is very different. Update is just small changes you are pushing, like application update, which we are doing from the app store. But upgradations are basically the enhancing or OS upgradations we are doing. So that's what we are going to prefer. And along with that, we have to change our application changes. Like I have to change the Java version for that compatibility of application, Java or Gradle version, Maven version I wanted to use. So that is what the requirements are. So that's where Terraform is going to destroy everything. Terraform is going to just destroy and use the same infrastructure, not going to use the, like right now you have 8 GB RAM. Okay, so the same 8 GB RAM or infrastructure is going to use by this 2019 server, and it will going to save a lot of costs. Right now, in the beginning, right now, what you did, you have given this RAM. What you did, you have given 128 GB of RAM for this application, but that is not in use right now. So after you are doing any upgradations, what you can do, you can make your server infrastructure for the 64 GB, and 64 GB is free for you. Okay, so that much of capability you have. After every kind of code you are running with the Terraform, you are running with the Terraform a code which you have initiated the code. Like you have to define that I wanted to have 64 GB for that particular requirements, and that's where your cost is going to be saved. Okay, so this is the beautification of the Terraform, why it is going to be immutable. We must be thinking like why we are destroying, but we are using the same environment of the servers. Whatever server data centers we are using, we are going to use the same. But in terms of the upgradations and the application changes, we have to stay with the latest changes which are coming into the industry. So yeah, that was the brief, and that's like similar what I've taught you, like service versions, like there are errors. These are two red and pink signs are errors, because like some service, some application in that particular OS are using old versions. That's where it is showing that these are not compatible with the latest versions what you have updated in this application, and that is going to cause you a lot of errors, and your application will be going went down. And till then you find your errors, what was the issues you did, that till then, like immutable systems are majorly building that server changes, everything they are doing it in a given time period, in a given instance of changes which are coming. So like you don't need to deal with these small stuff, so that like whatever errors you are going to resolve, your developers are sitting your operation teams are sitting, you are just working on the infrastructure, and they are just waiting for the upgradations of the system so that they can look that it is fine or not, the whatever changes they have done, it is fine or not, so that they look that they have made some mistake, they have to replicate that environment, or they need to go back into the previous versions, so they cannot do. But in Terraform you can do it. Okay, so that's clear. And okay, so Terraform is basically like that is the theoretical part. Tests are easier, version trackings are very easier, rollbacks are easier, that what I was talking about everything. So take care of configuration depth issues, version tracking, and the rollbacks are easier, and tests are easier. So that was the agenda. And again, how it is going to do, it is an agentless. What do you mean by agentless? You know the Kubernetes architecture, you guys already know. So you know master node is there, then there is a worker nodes. But in the Terraform, there is no master or worker node agenda. They have just API calls. They have just particular tool that is built by the provider itself. Like if we are working with Microsoft, we have to install AZ CLI or AZ client. That is a tool in our local system. In my laptop, I have to install if I'm doing the coding. So coders have to install. Okay. A client contacts the nodes and send updates as they are needed. So that tool, what I was referring, is that CLI equal to AZ client that you have to install, and that client will talk to these changes. And you must be seen Azure have a CLI option, PowerShell, or a Cloud Shell is already there. So from there itself we can configure whatever changes I wanted to have, or I can do it via the Visual Studio itself. So Visual Studio Code, we are going to install some of the tools which we are going to install. And so when a change is made to the infrastructure, each node is alerted on this, and then run the changes. Like suppose I have done some changes to this particular environment, this VM only, and I wanted to change it to the whole VM. So the API will get to know that I have to do it for all these environments and all. And my team members are getting to know I have done these changes. They are also getting to know about that. Like basically what was the developers are doing, they are collaborating with their team members. Similarly, infrastructure team is also collaborating to each other. Like whatever changes they are doing in their cloud environments, they are just talking to each other automatically. Like the updations are getting, like they are getting a mail, or they are getting pull requests, as well as changes are being reviewed by the team members or managers. So that we are going to look simple to manage a setup. This is very simple, but although we don't have a central control plane, so that is what Kubernetes has, central control plane. That's where like you have to talk to the master node only, and from that master node everything will be taken care by that master node. But in that we have API calls. Calls will be like one by one going to these not API calls are communicating to these particular machines and the environments. Okay, so this is a very important file, and you have to just remember this is the tf.state. I'll be using Visual Studio Code only. And okay, so basically this is the state file. This is auto-generated file. You see this sign is basically a Terraform sign, and provider.tf, terraform.tfval, and variable.tf. But terraform.tf state, which is not having a kind of what you can say extension, because this is not right now currently in progress. Once you run the code, once your providers terraform.var variables are running in that process, that's where your tf state file is updated automatically. That I'll be going to give you a brief on that particular logs. We are going to deep dive into the particular logs and see these, what are the changes and what are the states are changing, and automated updates are coming to the storage account automatically. Okay, so Terraform manage creations and manipulation of the resources. See, if I share this Terraform state file to anybody else, whatever, they will get to know whatever environment I'm running. Like basically this is a ARM template file, and this is a template file which template is telling the virtual machine is there, there is a virtual network is there, there is a subnet is there is a load balancer installed, there is a app service is running on, or there is an analytics service is running in, or any other service or a AKS cluster is in place. So that terraform.tf is having those information. Okay, if suppose these are got corrupted, we need to protect this anyhow. That's why we are sending by this tf state file, we can create another environment, or else suppose we have faced some disaster in the particular data center.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
We can re-spin up the same environment in another location. So in just given time period, in a small time period, or 10, 15, 20 minutes of given time period, that is infrastructure is spinning up if we have this TF state file cleared. Resource creation via Terraform creates an entry in that state, maps the metadata about the resources. Metadata, the basic information about the resources which we have been created. And basically this is the importance and the dependencies and the performance and the collaborations. Like whatever changes we are doing, we are going to upgrade every day, every second. Once you run your application, once I've done some changes in the Terraform or TF variable.tf file, it is going to be updated automatically before spinning up the environment. It is going to update this TF state file. This is the first job to create that. Okay. And then dependencies, then performance, then collaboration. Performance is why it is so important, because Terraform will refresh the state before each planning run, but it can be skipped. We can do that, but it is not recommended. We should not skip that particular TF state, because if you face some error, you are responsible. You are an engineer which is going to build that infra. You should update this file, because you don't know what will be happening with the infrastructure or data center. If some data center went down, you should be updated file in your location. Understood? Okay. This is the same thing, like reapply, reprovisioning, and that we know. And basically it is going to create those environments. We know that. And basically this architecture, which is basically this is slightly blurry, but it is a root architecture where we are creating a subnet, and then subnet is having another subnet, like subnet 2 is there, subnet 1 is here, and that subnet is basically connected with the our virtual network, because without virtual network you cannot have it. And another one is resource group. Like it is going like this, but it is coming like this. Like dependencies are changing hierarchical way. Okay. And then provider Azure RM, you have that provider Azure RM is giving an instruction to the resource group, like please resource group, please create this resource, and after that please create all these. Okay. So that's where dot location you have to define. You wanted to create to the east US, you wanted to create to the west US, where you wanted to create it. And the resource group name you want to define dot where dot resource group, that individually we are going to look into that. And that's the parallelly deployment to the multiple environments. Like I wanted to create thousands virtual machines. Like see, one virtual machine, if I'm creating that virtual machine, it is taking 10 minutes, and 10 people are creating 10 virtual machines. How much time it will take? 10 minutes, right? Whatever, like it will going to divide your work to the particular agents. Like the APIs calls are particularly with the services only. Like one VM will be parallelly running, one VM is also running, one VM is also running. That's why the spinning of infrastructure is very fast in this environment. And this is a collaboration with the teams, and how you can connect with the multiple data lake, data warehouse, and it's kind of a Google platform basically. Then you can take a screenshot on that. Like if data team is organizing some data, how they are going to organize with the Terraform. So they have some systems, and those systems are going to be orchestrated by the compute engine. And basically data lake is here, and those are the divided buck. Landing zone is created here, sensitive informations and the work, and then daily work which is residing here, and then backup, and then some of the information. Then marketing team is accessing those charts, and sales team is accessing something, and finance team is looking for the data application which is built. So that it is kind of that collaboration with the multiple teams. So basically how Terraform works. We have talked a lot about a lot of tools. We have talked about a lot of infrastructure designing. We have understood how it is going to be create multiple environment, how it is going to create workspaces, modules. We know all those things, but we still don't know how actually it is start working. We have downloaded Terraform in our local system, and now we wanted to start work. Okay. So what happened? Any kind of code, whatever I have shown you here, whatever things I've shown you here, whatever provider.tf, terraform.tf.state, tf state file, .tf state file, .tf var file, or .tf variable file which is created, these files will going to generate a plan. Okay. So this is right now codified infrastructure. What files I have shown you in the last slide, which I have from where I have came here, that slide is showing you files, .tf files, all those files which are here right now. Okay. Those, if I type a command, which command I'll be showing you, what type of command you have to type, that command will going to create plan. plan which is still not created a VM. Like I wanted to create 10 VMs, which is still not created that VM. But that plan is basically your ARM template, that finalized plan. Like this is what I'm going to be planning, or this is what I'm going to be building in that particular infrastructure. So that is like, you must be aware. Let me show you on like Azure portal what you do. Like I fill those information in that particular portal. I fill those details, like I wanted to have the networking, I wanted to have storage, I wanted to have the compute in the particular virtual machine. We select all those details, right? After that, what happened? That it is start review plus, it comes with the review plus create. Okay, that review plus create, where it is going to review your code. Similarly, Terraform plan is going to review your code first. So plan is a single template which is coming, and we can download this plan in locally, and we can use it to share to the multiple people or multiple team organizations for the similar infrastructure. So that is what the plan is. You can push that plan to the remote repositories. You can download this locally to save your time. And TF state is basically current state, and Terraform plan is also your current changes which you are going to build in your infrastructure. And we have public model registry. On the day 3, we are going to look public module registry. Similarly, it's kind of a GitHub where you can push your code automatically. And we just need to fill the details in our coding language. We just need to write, this is our like username and the password, and just go into that and just push this plan and all. Okay, so that's what we are going to do. And that public repository will be seen by the community, because this is a open source, and you can look for that, and basically it is going to help you a lot. So define resources, execute plan, apply to the provisioning infrastructure. So this is the process. And Ansible, I have taken this example to give you the basic brief, and that is already taken care by a few slides before. So DevOps people are here, you guys are here, you guys are in the same state, and we push the code to the Git, and that code went into the Azure DevOps. Okay, that code is went into the Azure DevOps, and then Azure DevOps get to know that Terraform is going to build this NSG, VMSS, or load balancer virtual machine scale sets. After that, VMSS should have application installed, Tomcat, and then some kind of code application should be installed. So that is taken care by the Ansible. So what should we run first, Terraform or Ansible? Terraform, right? So first we need to have the VM. Without VM, how are you going to install Tomcat and the other applications? So first we are going to create VMSS, and then LB, and then along with that NSG is also required, so that it will spin up that environment. After that, it will fetch that Ansible task which you have created in your CI/CD pipeline, and then Azure VM availability sets, where like VMSS, whatever configurations we have given, that will going to create that particular requirement for us. Understood? So this chapter is completed. We have wrap up the architectures, we have understood, but still we have to learn a lot before going to install the Terraform. So that's what we are going to do in this module. What we are going to learn, we are going to understand the Terraform installations. We are going to do providers, like what are the providers available, and basically what providers we are going to use, and the plugin based. Till now we have seen that a basic architecture, how Terraform is communicating to the other providers like AWS and Azure. But after that, we are going to use plugin based. Basically, the plugins, you understand the extensions which you are going to install for the Terraform, and then Terraform fetched providers. Automatically, Terraform fetches the providers and the workflow execution. So that we are going to cover. So let's go on to the Azure portal and let's create a virtual machine. I'll be creating a fresh scenario, totally fresh. I'll be creating a virtual machine, Windows 10. And in that VM, we are going to do all this stuff, so that I have running some project already in my system. So I'm not using that. So let's use like I'll be creating a data lab first, like data installation lab, not the what I can say Terraform installation, Terraform labs. Let's create this name and Intellipaat IP. Okay. So Windows, I'm giving the name only Windows. I'll be creating in East US. So you guys are already aware of such things. I don't need to explain these. Okay, username is here. Password I have to put. Okay, that's created. So that is what I was explaining. Review plus create. You click on review plus create. It will going to create a template. Okay, what is the issue here? So how much RAM I have taken? 8 GB. I need to have basically 32 GB. I wanted to keep 32 GB. Okay, it's created. So first of all, we are going to install in Windows. I'll be giving you a brief on Linux and Mac OS as well. but we are going to work on the Windows system with the Visual Studio only. So basically Terraform is written in Golang, and compiled as a single library of multiple operating system. It is basically already have all those details, like if you wanted to use Windows, Mac OS, Linux, FreeBSD, OpenBSD, or Solaris, any kind of tool you wanted, any kind of operating system you can use there, and you can have installations. Like it already just need to install a single tool, and that's your installation is going to be up and running. And in the Linux, you just need to install from this link. Basically, this is the main terraform.io is the main website, and till then it is going to be completed. So I'll be showing you some documentations. So that's where you are going to install for the Mac OS. This is the website terraform.io, and you guys have to explore this. It is mandatory to work with the Terraform with this website, because they have a lot of capabilities, and you must be going with the Terraform Cloud and Terraform CLIs. So you are going to work with that as well. So we are on Windows machine. Computer already detected that. This website already knows that we are using Windows. So it is directing me to the AMD or 386 versions. There are two versions. So for this is the OS versions, which OS is you are using. So that's where you have to click on it. That will start downloading. You have to wait for this VM, and we'll be installing this there. And then the Linux, similarly, Linux, we have the opportunity to download in Linux is basically via the command line. I just need to run these 3 commands, and it will start running Terraform. Or you can download here locally, and you can VGET. You guys know VGET. There is a tool which is going to be used to unzip the zip files, which is for the Linux operating system, and you can download it for the Fedora. You can download it for the Fedora and Amazon Linux, Homebrew, or CentOS and Debian and Linux. So such kind of tools you can install. Okay, you got it. You installed it, worked. So we'll be wait for this provisioning of infrastructure, and then we'll move further. And so Homebrew you can use for the Mac OS. You can use for the Windows, you can download directly, or you can use Chocolatey. That's a tool similar to the apt-get. You use that tool for the Linux, and Choco install Terraform. That will going to help you for your installation of that tool. And we need to have Visual Studio Code, and that we are going to install. Just wait for this VM to be spinning up. We are going to install Visual Studio Code. Why we are going to use Visual Studio? Because you can do all the work which is required. You can do via the command line itself. You can do everything via the command line. In Azure portal, how you can do it? You have the CLI here. And if you wanted to write some code, you wanted to push something, you can do it via the CLI. And if you wanted to open Visual Studio from the CLI, you can do it as well. Okay, that's done. Okay, there's a command. Maybe I forgot that. Launch the Visual Studio. There's a command. Okay, the code itself. So I just wanted to type the code, and I will be writing that code and saving that code in terms of that particular requirement. Let's go into that VM. Let's not. Okay, let's download the RDP file. Let me put the credentials. Okay, let's open the browser and let's install those 2 tools first. It is taking some time to install. Just a second. Just time to come up. Okay, so Terraform install Windows. That's it. So go to the first link, download this, and now just extract all. What you have to do is, this is the application. You don't need to run this application, and yeah, you have to use this folder, copy this folder, and put it in your C drive. Create basically create a Terraform folder only. Rename it. We are not going to click on that particular application. We are just setting the path variable, and then let's just look for the environmental variables. You must be aware of all these environmental variables, and just added this. And in this is a system variable. I'll be adding into the system path, added this, and in that, okay, just let me copy this Terraform folder first, copy the path, and then new, paste it, then done. Okay, and open PowerShell or CMD command prompt, and then run Terraform version. It's installed. We are going to use version 1.1.7. That is what we are going to use, and it is on Windows AMD 64 system. And you can look for few commands, which is basically Terraform itself. It's a command that is going to give you the details what you guys are using. And let me make the font size bigger. Okay, color itself, not the color, is screen text. Okay, let's make it. Okay, not an issue. So you guys can see that is what the Terraform is going to install. Terraform, we have the global options available. And in this command, we have init, validate, plan, and apply and destroy. So these are the main commands you have to remember, like just mug up these all commands. Okay, let's just install Visual Studio on Visual Studio Code, and I will be Windows. What I'm doing a next step. I have installed Terraform. I'm just installing a Visual Studio Code for my user. Okay, I've installed it for the Manish, and that is, I can do it for everybody as well as my user itself. So that's not an issue. Okay, that's I've done in the given time period. I have installed it. Okay, so yeah, why we need this Visual Studio? We are going to do the coding with the Terraform. That's what I have shown you. Like till now, like we know the Terraform, but we have installed this Terraform, or we are going to use Visual Studio to write the code, and then code will be sent to the Azure infrastructure to build the environments. So just give me a few minutes. I'll be explaining you why we need all these tools. We are going to install few more tools, and just follow my commands, few words, just follow my words for a few minutes so that you guys can all come together with the time. And we wanted to install Terraform here. We are installing Terraform extension here in the Visual Studio, not that Terraform which we have installed. That is a physically will be running for that proper applications. That is the only thing we are going to use. But now we are going to install Terraform here. I have opened the Visual Studio. Let me close it. If you are still having any doubt, let me close the Visual Studio. Let's type the Visual Studio code, not the Visual Studio 2019. This is a Visual Studio code, lightweight application from the Microsoft itself. This is a way lighter than Visual Studio in terms. So I went into the extension. This is the extensions, and I have to install 3 extensions. First is Terraform with the name itself, Terraform. Okay, so this is the one I wanted to install. This is Anton Kulikov. This is the name of that person who built that tool. And another one is the HashiCorp Terraform. It is official tool from the my HashiCorp that we have to install. HashiCorp is the company who built that tool, who built Terraform, Vagrant, and Packer tool. Understood? And another tool is Azure Terraform that we wanted to have because we wanted to connect to the APIs of Azure. So that's API will be connected with this only. And one more tool we need to install, Azure CLI. Okay, so Azure Client or Azure CLI, you can type in CLI install. Okay, in this, just click on latest release of Azure CLI. Why we are using, I'll be giving you the brief after the installation. Just hold on for a few minutes. We are setting up the environment. Everything is required. So those are installed. You can see if you click on disable, it will going to be disabled. If you click on disable, so that's already done. And let's go into the Explorer. That's where we have to create a folder or open a folder. So what I'm going to do, I'm going to create a folder, Terraform exercise, Terraform labs for Intellipaat. Or Terraform labs, that's it. Let's not make it complicated. And that folder will be opened here. And that is an empty folder, and that's empty folder is opened here. Nothing is there in that particular folder. That's it. Okay, you are almost ready. Carol is almost ready with having Azure CLI installed. So we are just installing the Azure CLI. I'm just one step behind you, Carol. Okay, let's install this. First of all, I wanted to log into my Azure account here. So let me close this tool again. So till now, let me open a notepad and let me give you a brief what we did till now. What are the tools I have installed for the Terraform setup? Terraform itself, Terraform tool we have installed. Another is Visual Studio Code, and another one is Azure Client or CLI, and another one is extensions we have installed. Extensions, what are the extension? Terraform extension itself, then HashiCorp Terraform extension, and extensions in Visual Studio. Okay, and another one is the Azure Terraform. Perfect. So let me put it in the chat. What are the if you wanted to set up a new machine, what are the things you want to install that you are going to install? So now let's look that our Terraform is working or not. Let's just verify the few steps. Let's open the Visual Studio. Visual Studio is a kind of a code generator. You can use any other code editor. You can use any other code editor you wanted to use. There are a lot of editors available, but the Terraform is very good working with the what I can say the Visual Studio. So we have some functionalities here? File, edit, selection, view, go, run. Run is for the running our code. Basically, you need to click on terminal. Terminal is basically your command line. So command line is coming here. Okay, so you have the GUI of your code. You can see what you are writing. with the terminologies, which is going to help you a lot. Those extensions, what we have installed, those extensions are going to help us. Okay, to write the code. If you are writing some wrong syntax, that will going to help us. Okay, so here we are seeing Terraform, it's running. Now let's clear this. Now type AZ login so that we can get into the Azure account. So yeah, okay, we need to restart again because it takes a lot of time again. And then command line AZ login is working or not. Okay, we already have, but it's not showing. So maybe we need to reset up our application. What you can say, restart our Windows machine. That is what it is saying. So that PowerShell, let me open the PowerShell. AZ login. I have to restart the system. Sometimes this CLI takes a lot of time in terms of, let me restart the system. Restart. Yeah. So let's wait for that VM to restart. Let's put our focus on the plugin based architecture. What we have done till now, let me again talk about that. We have installed this process, we have done this setup, and that is required to have. That is once you are in Terraform aspects, you have to install these. You have to have all these installation tools. So we have already restarted that virtual machine. We have restarted. After that, we'll be looking into that. First of all, let's look into the plugin based architecture. What is plugin based architecture? So this plugin based, if you are a developer or if you have worked with any programming language, you must be aware of the RPC, remote procedural calls. So that's what the calls are going to be done. So provisioners are provided by the Microsoft, or basically what you can say, Microsoft or AWS to the HashiCorps. They will give this detail to the HashiCorps that this is our provisioner, this is our provider, and you have to use this provider to create infrastructure via this plugin. You install this plugin, whatever plugins we have installed in that particular, what I can say, in the Visual Studio, I have installed this plugin. Okay, those plugins or extensions are equal. So these I have installed, and these are going to help me a lot in terms of creating my infrastructure with the particular language, particular cloud service provider, AWS, GCP, or Azure. So it is written in the Golang, and there are some libraries, and we have a Cloud Vendor API that I've already discussed. This is the API which we are going to come in, and that API will be communicating via the HTTPS port. Understood? This is a plugin based architecture. Terraform is not using, if you are aware of Ansible, if you know AKS, you guys already know AKS, that's where it uses client server model. Like there is a master node, there is worker node, but in this we have to install plugins. That's it. And after that, we don't need to install any other tool, any other requirement. We don't need to align with that. Okay, clear? So the communication flow, how this communication starts. The Terraform is already installed in our system. That's I have shown you, which we have done. So that installation is done. After that, what we did, we have providers that I'll be showing you now, upcoming slides. After that, we have Go language. With that, like it's built on the Go language. After that, it will go to the client SDK. And after that, SDK is basically software development kit. If we have Visual Studio in place, in that Visual Studio, it will talk to the remote API. So let's go into that particular virtual machine again, and let's connect. And I have two screens, that's why it's going to another screen. And Manish, this is the password I have to type again. Okay, there's the VM. Let's open Visual Studio. Is at login. This is the command we use to get login into my Azure account or your Azure account. So that what we have installed, it will open a browser. So it will open a browser automatically. What happened? Okay. So let's do it. Let's Control Z. Let's close this. Let's terminate this. Let's again go into the Visual Studio. We are not doing with the local CLI. Let's go into the Visual Studio. Type AZ login. Now it will take us to the Azure account. For a login into the Azure account, I have to give my ID, correct? It will send a code to my mail ID, and in that I'll be able to log in into my account. That's done. You see here, not here. Here itself, it will start fetching the subscriptions available. So right now I have Azure Pass subscription. I have these subscriptions available. So that is going to show me that state. Okay. So let me show you those subscriptions available on the portal. Okay, portal.azure.com. Okay, so we are in that, and we have the subscription, Visual Studio subscription right now, and that subscription is enabled, and you can look subscriptions from here itself. So that's a subscription I have right now in place, and that subscription details are here. Okay, in that subscription I'll be going to create everything. Okay, perfect. So till now we have done a small setup what required to create Azure Terraform setup. So that we did Azure login and given username and password, or else there is one more way. You can give subscription ID and secret ID. That I'll be doing with the labs only. Secret ID. Okay, so these information you are going to give into that particular VM. So that let's close this VM. Right now we have the setup, we have the folder Azure Labs. We are going to create multiple files and we are going to provision the environment. Okay, so now we know there are some plugins which we have to install. Okay, now we have done those installations. We have installed those plugins, which are all plugins are also written in the Go language itself. Okay, so we have this distributed. The plugins are distributed by the HashiCorps, but created by Azure or AWS or itself the Azure like cloud provider companies. Okay, so this is the basic theoretical concepts that we are going to look again, and so this is how like writing the code. So provider AWS, it's here we have to type Azure RM. Azure, if you're talking about Azure, we have the provider name Azure RM. Okay, in Azure the provider name is Azure. You guys can have the notes on this. This is very important. Azure RM is the Azure provider. AWS is itself AWS provider. So the provider name itself is AWS. And how you write a provider? You first provider, then double quotes AWS or Azure RM. You type Azure RM because we are dealing with Azure. Then after that you write your details of your provider, and after that you can like basically in that you are going to type the subscription details and all. That's what the different way I was talking about. Subscription ID and resource group ID, where you are going to build details and all. So that those details are you are going to mention here. Okay, so yeah, this is what like provider is basically. And after that there are like 125 plus cloud providers. Some measures you can see below. These are the below provider: Alibaba Cloud, Oracle, AWS, Google Cloud, Azure, VMware. So we have discussed this. Now there is a communication. How this communication will going to work? Okay, so basically Azure, there are certain files. First of all, remember these file names. First, I have already told you there is some files, provisioner names, .tf, secret .tf, such kind of files will be there. So first of all, we have the file name is main.tf file. Okay, this file is basically similar to your master branch in GitHub if you have been went into. So GitHub or master branch which you are using. So this is what it is going to create all along your connections, your creations of the resource group. And there is another file which is called variable.tf. So these are just naming conventions you need to remember. These are the variable.tf. We have output.tf. We have, and along with the variable.tf, we have terraform.tf wheres. This is the file. Understood? So such files which we are going to use in this, we can have we can define providers in this itself. Providers we can define here, or we can create another file which is known as provider.tf. Okay. After that, there is in Azure or in AWS, you see this AWS provider. If you are learning Azure, you can replace. Let me replace with the Azure, and it is going to do the same job. Azure. It is an Azure provider now, or it's an GCP provider, and then it's here. What you make it a resource group, RG resource group API. Okay, and in this EC2 instances, you can have virtual machines. This is similar EC2 instance equal to virtual machines for in AWS in Azure. So you are getting few more information about AWS as well. So Azure, we have a resource group API, and that resource group API is inside that we are going to provision our virtual machine and resource group as well.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So resource group API will get to know that we have to need in can you tell me if I'm going to create a virtual machine, what are the things I needed? First, let me add one thing, virtual network I need. What are the other things you guys can think of? You cannot create a virtual machine without having virtual network or subnet or public IP. We can ignore. Private IP is must. Okay. Similarly, we need to have NSG as well. NSG is also going to come into the place. So such kind of resources which are all dependent to each other. If you are going to create a VNet, that is coming with the subnet as well. So that's the dependency, that's the hierarchy. If you are going to create a subnet or for the VM, you have to create a VM with the subnet as well. So that's the hierarchy based structure in Azure or in any kind of resource group or any kind of your infrastructure provisioning phase. So that's where you have to define. If you're creating VM, you have to define all these structures. Everything you have to define by yourself. In the Terraform files or those things where you are going to write in the main.tf files, or else there are a lot more ways. In the main.tf files you can write, or else you can create vm.tf, vnet.tf, but the hierarchical order should be same. Then VM should be first coming, then vnet, then subnet.tf. But this is not preferred way, because you are going to basically this is preferred once you are creating workspaces. So that workspace is for the multiple environments you are going to create, dev, prod, and UAT. But these are very small resources. These are just a VM creation. So that's why we are not focusing on that. But a main.tf, you guys need to remember there's a main.tf where we have to, what are the components we are going to install? We have to write all these components. Understood? Clear? And this is the main.tf. We have to write everything in this main.tf. And this is our configuration files. How we are going to write. This is our local machine. Right now in our scenario, this is our local machine. What it is? This is our virtual machine, Windows 10, which I have created, where we have installed all the tools and Visual Studio is there. And this is the machine which I'm referring to. Clear? Okay. And now let's see how you can write the provider. This is a term of provider, basically. So, okay. Now we have to write a Terraform file. First, if you wanted to write a Terraform file, you have to define provider first. This is the first thing you have to do. This is the basic thing, provider you have to define. What is the provider? You already know. You are going to work with AWS cloud. You are going to work with the Azure cloud, that you have to define. Or else you are going to work with both the cloud. You have to write here itself. Like Terraform, this is the command you have to use. This is all available on the internet. You just need to copy and paste and just define Azure you wanted to use or AWS you wanted to use. Just slightly it will be looking complicated right now, but it is very easy. You just not even think into the syntax, context. You don't need to remember all those. That's whatever I told you, like you need to remember these file structures, you need to remember anything. But in Terraform, you don't need to remember the code. There is all available on the internet. Everything is available by the Terraform itself. They have given everything. Okay. So you don't need to worry on that part. So it will ask required providers, like my cloud, I can define here as well. So my cloud, I can define source double quotes Azure RM. Azure RM is the provider name. So make sure Azure is not the provider. Azure RM, resource manager, is the provider. And we have to define the version. So in the next slides, we'll be looking into the versions. And this is the exact Azure RM we are going to write. I'm going to create Azure resource group. In that, basically, this is a syntax. This is a high level syntax of Azure providers. And in that, basically what you have written, this is a 0.1 version right now, 0.12 version is there, and 1.0 version was there. And then required provider is Azure RM, and that is the like HashiCorp/Azure RM. That is basically coming from the HashiCorp, and this is the Azure RM, and this is the version we need to use. Okay, this is the version we need to use. This is the version required version, the like basic version. At least you have to have this, and like greater than or equal to, like from this greater than 0.12 greater than right now what we are going to install 2.0. 2.0 version we are going to install. Understood? This is basically Terraform version, and this is provider version. Clear? Understood? Some providers can use shell environment variables as value for the sum of their arguments. So this is what source and the versions, these are the basically arguments which we have written, and that's really pretty easy language. I think you guys can see this is very pretty and easy language. Clear? So in this terminology, what I have written here is this is the equal to, or like this tilde sign is basically saying that which version you wanted to use. It is like I can use 2.0, or if any upgraded versions comes into the picture, automatically fetch that version. Okay, so that what like basically like I cannot use below that 2.0, but I can use more than that. So it is basically written like this. You can go through that. Basically these example Azure provided the authentication information could be supplied through an environment variable or cached credentials from the Azure CLI. That's where I have installed this particular tool. This tool I have installed because I don't want to write my environment variables details in that particular subscription. Okay, I will show you how you can do it. If your client want that, you can use that, but that is not a recommended way. You have to use Azure CLI and you fetch the information via the CLI only. And these are the naming, like basically you know the maths, basically greater than equal to is greater than equal to, less than equal to, and this is one funky which is basically whatever range of this coming, like that was I was referring basically. Okay, so suppose I have chosen this 2.0 basically. So what I can do, there are 3 digit in the versioning, like how HashiCorp launches the versions of the provider equal to 2.0.0. Like what I can do, I'll be using 2.0 is the fix, and after that 1, 2, 3, any other new versions, like in the last dot, if they are coming, I can change that. So we are going to do the labs on that exercise we are going to do, but that is not the case to discuss. You have to install the upgraded or latest version always. If you are using HashiCorp, like you can say, if you're using Terraform HashiCorp tool, you have to use latest one only, latest and latest always. But you have provision your environment and there are some changes comes into the picture, and suppose you already did your environment change. Okay, you have created your environment which is running right now, created environment you have. In that environment, what could happen, like because they do some syntax changes, they do some kind of application changes in the particular Azure ARM or AWS. Okay, so what you have to taken care that we are going to learn, like we can lock a particular version of the file, like I will be using this only, and let's lock it out. Let's not upgrade to another version, or let's not decrease to another version, that we are going to look. So these are basically going to get the credentials, key secrets, everything it is going to get. So that's we already did, and this is a step we did. We initiated AZ login we did. So are you guys getting comfortable with the Azure ARM and what I can say Terraform? Are you getting it, or still getting confusion and all going good now? Like what we did, we are showing you on the slides and we have already done it, and I'll be sharing you this so you guys can practice it out again. So let's move further. So basically what versions I can use, I have shared you this. Anybody give me answer anything? Basically we are going to get the 2 answers from this. So what would be the answer? What could be like, but basically we are going to use 1.1.0, which is tilde sign is greater than that. So what version I can use, I have shown you this here, and this is the example, like 2.0.0. After that 2.0 to 0.1 2 3, which could be coming in that, I can use this example. So what could be the answer of this particular question? So basically see, and this is the exact example I have given you, and this is like in examination, if you are going for the Terraform certification, these are the questions will be coming. Clear? There are 2 things we are discussing. We are discussing Terraform, and Terraform should be installed always latest, that already I told you. And if you go into the upgrade, there is a command upgrade. I'll be showing you that from there itself Terraform is already getting updated. Okay, update or upgrade, there are 2 commands, so I'll be showing you that. So that is automatically done. Another one is provider. That is, let me share you that itinerary in that brief. Basically this is the one which I'm talking about, the providers. Okay, clear? Please don't get confused on that. This is, providers are different, and providers are basically 2 types. How Terraform fetches providers. Now we have one topic to discuss, which is very important in terms of basic understanding of creation of resources. Basically HashiCorp distributed and the third party itself. So there are a lot of companies, they wanted to get into the Terraform so that people can use their data centers and all. So that's why, but right now there are three big companies, Azure and AWS and GCP. We cannot compete with these big giants, so that like small companies are also building, third party companies are also building. Okay, so there are a provider which I'm going to talk about, Azure only. That's why Azure RM is the provider name. Azure Resource Manager, ARM, is the provider. Okay, you guys know CloudFormation, Azure RM is there. And let me make things clear to you guys, like how you can make yourself be more, what I can say, exposed to the cloud and be more exposed with the Terraform. So this is the document. So this is the Terraform provider. Suppose I wanted to create a resource group. So I'll not be writing everything again and again. So let me share you the resource group one. Where is R? This is the, where is resource group? Find resource group, authenticating the slides, data lake. Let me look into the small code. Virtual machine is also there. Okay, where we have virtual machines, Spring Cloud, Cloud Sentinel. Okay, this is the complete one. Okay, so you wanted to create a Linux virtual machine with the Terraform Cloud. You just need to come in. This is the official document. You have to follow this. This is the registry.terraform.io. You guys just, this is the understanding which I'm talking about, but the code, everything is all available on the internet. Everything is all available. Okay, so in this, you go and you see providers, Azure RM, and I haven't given the version here. Why I haven't given? Because I wanted to tell to this particular file that you need to download latest one only. Okay, whatever is available, latest one should be preferred by me. That's why I haven't written. But in the slides, what I have written is, I have written some versions. Okay, I have written this HashiCorp Azure RM versions that I have written here. But I don't want to use the versions itself. I'll be like, versions are basically automatically fetched by Azure. After that, this is the basic code. You can understand resource. I wanted to create a resource. That resource is, if you see this itinerary, another one terminology is resource. Okay, so that resource I was talking about, like what kind of application you wanted to create. So after that, I'll be saying that I wanted to have a resource group, and this is a local name. This is for the Terraform, like what you wanted to create. Example is not the term. We have to change this value, and Azure Resource RM, we can fix this value. And after that, name, what is the name of the resource group? You just go into this and create and resource, like Terraform resource. So two things I have to fill in. One is subscription, another one is the resource group, and another one is the reason. And here subscription login I did, AZ login I did. So I don't need to give that detail. Okay. After that, I have to give the detail about my provider because I need to use Azure RM. So that information is mandatory, and that information should be on the top of our files always. After that, I have to write resource. I want to create a resource, and this is the all similar code. You see, everything is very similar. And I'll be giving you a small dose on that. But yeah, like if you can write till here, till this code, if you can understand, you can write any kind of code in the Terraform. You don't even need to look into what you are writing. Just writing and copy pasting and just changing your names, commands, and everything is available on the internet. And that is why Terraform is very, very good, because the documentation is very special for the Terraform. Okay, so this is like resource group. I wanted to create this. What I'll be going to give you the demo. So what I'll be copying this everything, and I'll be putting in my resource group. And what I'll be doing, the example resources, I have to change the name of this. I have to change the name of this example, and that's where I have to change. Similar here, values I have to change, and that's, I'm good to go. Everything is good to go. I can create easily. I can call, like this is basically a resource. I have to call this resource to here. Okay, so what I'll be doing, resource Azure resource group dot example dot, these are the variables which are inside this, and those variables will be called here dot location. So location I'll be fetching from here. This is the West Europe location which I wanted to use. Correct? Clear? Okay, we have come to a position where we can start writing the code. Okay, let's create a resource group. I'll be creating a resource group. Okay, so that, okay, just need to copy this first. I'm deleting this. After that, I'll be showing you another scenario. First, I'm going with the very basic approach, main.tf. single file. After that, I'll be going you multiple. And Terraform is basically known for the copying the code. You have to rely on that, but intelligence is yours. You have to know what you have to change. What is your requirements? Logic for loop you have to apply, like for loop, and the other connections you have to apply, like how many VMs you wanted to have. So that is a normal understanding. I'm going to create a Terraform role resource group. Basically, this is the service name, and this is the local name. Okay, this is my local name, and this is my provider, and provider should be always there. If you're using Azure AWS, what you can do, I can write here itself provider, and I can type space AWS and then features. This is basically the terminology. If you don't add the feature, that is not necessary. Okay, so similar you can things you can do for with the way that you can create. But let's remove. We don't want it to learn our AWS for now. Let's create this, and after that you open the terminal. I have to type this command. You have to remember all these. Basically, this is already there. You can look for the details here. We can write some commands, and you can look forward with these commands. I'll be showing you these commands, but for now, just 5 or 6 commands, and that is very good. If you write git clone and all, you need to know git fetch, you git pull push, or similar commands you are writing. Git initialize. What happened in this? If you see this white logo which is coming here, that means this file is not saved. Control plus S you have to type. After that, you see that is gone. After that, I have to type Terraform init. After that, you see finding latest version of HashiCorp Azure RM. I haven't defined that. That's why it is finding the latest version already. Okay. And installing HashiCorp Azure RM. And that is a version which is basically shared by the HashiCorp itself. And there is a file, log file. I'll be talking about that. But for now, let's leave that question. We are going to create a resource group into the Azure. Terraform plan. This is the command, another command, Terraform plan. That plan basically going review plus create. That will be going to done by this code plan. And there will be, you see, there are certain files are coming in. tf.state is coming here. That we have already talked. A tf.state is coming here. Log file. tf.log.hcl is also coming here, and it will take some time. And after that, information like this is on hold right now. Log file. That means your versions of the code is logged here, and that is gone now. So you see, those files are gone. What is it saying? Terraform will perform the following action. It's not created right now. Terraform will perform the operation. That means a resource group will be created in West Europe, and the resource group is name is Terraform role RG. That is what it is going to be created. Understood? These commands, I have the documents, I have everything. You don't need to worry on that commands. These are very basic, and you can remember anywhere, by the way. Okay, so apply is the final command, and that is going to create the source. You see, Terraform state file is coming back, because whatever I'm writing, I need to lock my code so that my team members, which I'm sharing my details, they should not write the code again similarly. So that we are going to look, but right now it is going to write the code, and it is going to perform the things, and it will ask, do you want it to do it? Yes. And then it will start creating. See, if developers are building the applications, if we are building the applications, if we are managing the infrastructure, see where you have the tracks, like it is created now. It is created, and let's re-verify, and which one I have created. Let me see what is the name I have used. Terraform role RG. I have to refresh it. Portal is getting updated. Just wait for a few minutes. Where it is created. Just a second. Let's see the logs. Subscription, and then the resource groups. This is a subscription ID I have. Okay. Did I mess up with my subscription, or I did some mistake with the subscription? This is the subscription ID which is not matching with my code. I don't have any other subscription. Okay. Global filter, all. Okay. This is the ID of my subscription. Just wait for a second. User login. Why is it taking Azure Pass? And it took, okay, now it took Visual Studio Enterprise. Okay. These commands are basically you have to rerun again. Apply. So like, are we guys back? One thing that I missed in that particular script is I have multiple subscriptions. So that I have to define my subscription, which subscription I wanted to use. So that I defined and it worked fine. So I just added my subscription ID. Like I was using a default one. It was using default one. And then we changed the subscription ID, and then I create this initiation of the plan. This is the command which is going to make your whole folder to a Terraform like restricted folder, so that in this folder I'll be explaining few more. So yeah, I have to explain so many things in that. And if you can understand this, 50% of the Terraform is completed, and 50% of the Terraform is going to be completed in the next 2 days. Carol, do you have any question? It worked for you, I think, like the similar stage you are in. So that's good to hear. Mine worked and showed in 30 seconds. So yeah, it was building my subscription, different subscription. So I just looked into the ID. I changed that ID. I put my ID here, and that worked out. Okay. So if you have multiple subscriptions in your list, I have multiple subscriptions. That is why I was not seeing that infrastructure which I built. So I'll be going to change the name. Like I'll be taking a name again, and like Terraform role resource group check again. This is the resource group which I'll be creating, and you just please focus on this, how this state is changing, these files are coming and going out, and all those things are happening. So Terraform init, this is the first command. Then it will start locking this file. You see that lock file is there, that is went out, and then this start locking the file. After that, let's clear this Terraform plan. It will create a plan for us that what should be created in the future, what should be created. Like that is the validation, that is the importance of the Terraform, that it is giving you a validation that it should going to create this. Let's wait for a second. Do we get the info file, that log info file, and your infrastructure is okay. I have to save this. Control S I have to do because I've done the changes in my file. Then again, the Terraform plan, it will look that is there any changes you have done in the code, anything you wanted to have it, not. And let's open the folder where this Terraform labs is there. Let me find where I have created. On the folder where I have created. Okay, I have created in the desktop on the user. Okay. So this is the lab. You see, there are multiple files are coming. I have just written this file only. These are all came after the initiation. This is a log file. This is a state file, which I've already explained. This is another backup file of this state file. Okay. So these two files we need to secure anyhow. And log file, which is going to log the versions, whatever versions are available in this providers, it will going to log that. So this is what it got installed from the Azure Works automatically. This is the code decided in the folder. This is the application which is downloaded by Microsoft from the Microsoft, but it's from the Azure Works for the Microsoft. Clear? Okay. So what it is going to create, and okay, it is going to replace that, and these services will going to destroy one resource group. It will going to create a resource group. So because I haven't changed the local name, this is a local name, I have to change the local name as well. So resource group, resource RG, change. Let's save it. Control S. Then let's move to the plan. Again, let's plan it out. You see, these are the logs, and this resource will be destroyed. This is what it is saying, that you have removed that code, and that resource group will be going to destroyed, and this will be created. So RG change is going to be created. I'll be creating that. And if I've copied this code, and another resource group I wanted to create, I can create it. But for now, this is the information. And you can see in this plan, what are the written here? 1 will be added, 0 will be changed, another 1 will be destroyed. Destroy, you know them by the word, it will going to delete that resource group. Right now, let's look into the resource groups. What are the resource groups are available? I have this resource group available, which is going Terraform role RG check, which I've created, that is going to be deleted. This is the name of the resource group. It is going to be deleted. And now this is going to be created. And the reason location are different, that like the West Europe I am creating. So let's create it. Terraform apply. Done. You see, this log file came in again, and after the creation, it will go away because what is happening in that, I'll be explaining that. We are coming with the slides. There are a lot of things are happening. So we have to type yes, or you can type auto approve as well in the particular command, Terraform apply hyphen auto approve. Automatically it will approve that. Yes or no, you don't need to write it. Okay, it is destroying, it is clearing, then it is complete after 1 second. It's showing that it is going to be completed in after 1 second, and this is the resource group ID, or this is the subscription ID, and this is the resource group which is going to be created. It's still destroying, it's still creating. That done. Now our services are completed in 17 seconds. They have created and deleted a resource group. So if you are asking that question, why Terraform we should use, because first, that is faster, way faster than you can expect. So if you are going to create by the manually, this is, and along with that, you have the history. You have the history, you keep the history, whatever you are doing, you have those histories, and you are doing with the backups, whatever you are creating, you can do it. And you wanted to create another environment, or you wanted to create another resource group, you just copy this folder, you change the name, and you spin up the environment with the different subscription or different resource group you wanted to create. Clear? That's pretty much it, what Terraform is going to offer. So we have seen this, a Terraform in it, and this is, let's move back to that particular machine. In this is the folder which got created. In that folder, you see .exe file is got windows.amd. In that there is a file which is, this is the exe file, which is a Terraform Azure RM provider. This is the provider. When it got downloaded, once you clicked on Terraform init, it will look for this code first. Like provider, which provider you want. Terraform init will look and download this provider. Understood? This is already downloaded here in this folder. If you delete that, if you delete this folder, it will automatically again start downloading that. Okay. Or you click on upgrade. There is another command. I will be showing you that as well. But for now, it will install. And this log file, we are going to look forward with that, because this log file is very important in terms of lot of deployments are happening. Suppose me and you and like Carol and Karen and me, we three of are working in the same company, and three of are going to create an infrastructure, and Peter is just managing us. And what happened, like he has given all of us to a single rights, like we have the admin right, we three of have admin rights, and Peter is the owner of that subscription. What happened, like I'm also creating the resources, I'm also creating the virtual machines, you also creating the virtual machine, Carol, Ken, and three of us are creating virtual machines at the exact same time. So what could happen, this Terraform state file got hampered with that way. You cannot deploy multiple sources, like from the different sources, you cannot do that. Okay, that's what happened. Like once I click on the Terraform apply, it will log that file. You see this, the log is there, it will lock that file. This file, these all infrastructure, this state main.tf got logged. Like that log means you cannot do the changes. If I am doing the changes, Kenyan and Carol will be getting an error in the particular resource group. If you are getting that, it's already there, but let me show you that where it shows refreshing the state, it shows locking it file and then deploying it. Let me show you that. Terraform init, and then initializing the fork, and then Terraform. Okay, yeah. So it's where this is the refreshment of states. It will change that state, and what are the changes are going to be coming in, that will do. After that, let me show you that. Yeah, it will going to apply with the refreshing the states, and it will lock that. In that state, it will lock automatically. And let me show you how it going to lock. Let me change the main file again. Let me copy this and let me create another resource group. Copy resource group. I just copied the change, but I have to change the local name, rg new, and I have to change the resource group name as well. Okay, and I'm going to create this in EastUS. Okay, now Terraform init. Just focus on these changes. Whatever changes are coming, there are info file which is going to log this file. And then by the name itself, log.htl, Terraform HashiCorp configuration language will going to log it. And providers are downloaded. Let's save this file first. Control S. Okay. And Terraform plan space plan. It will generate, and you will see the logs that how it is going to be creating. You got that file. This is the log file which is coming in to log our infrastructure. Okay. So that it is showing that what it will going to create. So RG resource will be added. Now this is already there. I have created this. Now I wanted to add something in that. So what it will do, it will going to create that. Okay. So Terraform apply. Okay, command is wrong. This is the provider one. This is the log file. This is the state log file. This is the Terraform log file. This is the Terraform state log file, which is coming once your creation of the resources are going on. After that, it went out.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And then a Terraform state file, which is the main file of, and another one is a Terraform state file of the backup. And Terraform state file is having the latest configurations, like what you have done, what you are going to do, and the changes, like what are the creations you have done with yourself, with the particular resource group and the subscriptions. So you see, you explore this file, you will get to know there is a version which is we are using, serial number, the lineage and all, like the scripted code are there. And after that, there is a mode of the resources, resource name detailing, and the Azure RM is the type of the resource. This is the resource group name, and this is the resource group name again, where it is going to deploy. Such kind of things are going to be created in this particular file. So it is written in JSON, and it is basically, you guys can just copy this and paste it in ARM template, and you can use that as well to spin up your environment, or else you can spin up your local environment. You can spin up your main file TF files via this environment. So that we can going to see. Cleared. Let's move on to the few topics which we are going to cover quickly. Okay. So the providers we have seen, and automatically download providers. That's what I have said. And the user plugin directory. This is the directory that we are going to create now in the upcoming classes. But the plugins which are downloaded that we have seen. And now that is fetched, like first Terraform initialization, Terraform init. I click on the Terraform init. What happened? It will go and look for the provider which is going to be used. So first step is here. It will, this is a command which we need to type, Terraform init. Okay. And after that, you have this. It will go and it will look into that particular main.tf file which you have created. Okay. Main.tf file. After that, what happened? In that, it will look for the provider. You have to have this. Like if you don't have this provider information, it will throw an error. You don't have the information, or your file is not completed. After that, what it will go? It will retrieve the provider information via the plugins, or it will go on to the internet, go on to the registry.terraform.io, tf.io directory. I will show you that as well, registry.tf.io. There it will fetch that particular file or that folder which I've already shown you. This folder, this is the particular folder. This is the provider file, or this is the folder. You see providers. This is the provider file. It will fetch that. After that, and it will check default versions. Any versions are there, anything there, and store them into the particular repository directory. What you can say, that directory I have shown you. This is the final step. This is second number, third number, and then fourth number. Then it will go to the 5 number that is going to create .terraform, which is mandatory to have. If you are going to deal with the Terraform, .terraform file folder will be coming in your way. You have to look for that. You have to understand that, and how it is working. If you are working with any other team members environment, what are the preventions you have to look for? First, the provided version. You have to look provider version. Another one is, do they have Terraform folder, .terraform folder? So these two information you need to look forward. And let's move on to the next slide. Understood? Okay. So Terraform provider, basically Terraform, you know that Terraform is going to work with multiple providers. And we can use that in a single file that I already discussed. And that topic is basically cleared. We just need to look how that we can write it. So if you have Azure, if you have AWS, we can write it. Scenario could be using multiple different providers. Scenario could be using multiple instances of the same provider. Multiple instance, what do you mean by the instance? you wanted to spin up multiple resource groups, you wanted to spin up multiple data of the like you wanted to create a database with the multiple names, so that you can spin up with the same provider. So that is going to help us in that formation. Okay, and that you guys can read out. To optionally define multiple configuration for the same provider, that we haven't done, we're going to do it, but we are not focusing on this line. We are just focusing on the Azure, because we are not dealing with the AWS right now. We could do a lab with the GCP, that I have to figure out how we can do that. So each additional non-default configuration use alias metadata argument, and that is the details. And right now it is not mandatory. We don't need to use that. We can have that in the upcoming classes we are going to use. And this is the basically the Google. If you are using Google is itself with the Google provider. So Google's provider is basically the name with the Google only. And Azure Resource Manager, because we have ARM in Azure. So Azure Resource Manager RM, that's why we are using provider Azure RM. And in AWS, we have seen this is the AWS one, and this is for the Azure one and Google one, and GCP is going to create this. And now we are going to learn how these configurations are written, that we are going to talk. Okay, variables, we have to define the variables, we have to define the details, everything. We are going to look into that. That is coming in module 3. Okay, before that, we'll go with the module 4, some of the topics we wanted to understand, then we'll move back to the module 3. So that is all clear. And you see, this is the provisioning state, this is the version, this is the Azure version, this is the Google version. Like I can add all these code and it can give me the template version, Google version, Azure RM version, AWS version. That is all whenever I wanted to use. And this state is called multiple provider with different cloud service provider, cloud service CSP, basically. Clear? So default, how you can write this is the syntax, and that we have discussed. And basically in Azure, in Terraform, you have the versioning. So if you wanted to use ARM, you can use with this way. Azure Resource Manager, you wanted to use AWS, you can use this way, and you can define that clearly. So there is a one. Any doubt till now? Anything like that we have discussed, and we have come along good way. We have completed good things today. So again, you wanted to say something on that point, like you are confused somewhere, you wanted to ask some questions and how it is working, that we have discussed earlier in the first slide. I've added this. Why I'm revising this particular, because there are few pointers which need to be discussed after whatever we have done with the providers and everything. So this is the provider discussion. That is basically the workflow of everything, how communication is going on. First command I typed, so like we typed Terraform init, and then we type Terraform plan. That plan is going to create TF. That plan is going to connect with the TF variable.tf and the main.tf and output.tf. And similarly, that is also going to connect with the main.tf, output.tf and variable.tf. And this is basically created on the backend. I've shown you this is a .tf file, and apply I did. I haven't done the destroy. Let's do that destroy. Clear Terraform destroy. These are very basic command, just typing and solving your queries. Now, whatever resource group were there in our RG, whatever RG were there, that is going to be destroyed. Okay. So again, an RG check, and these are two resource group which we have created, and I'll be deleting them. Or these all going to be deleted automatically. Destroyed will be destroyed. Right now, I have applied and I have to create that. It is going to be destroyed. So that's where like I have created 100 of VMs. I wanted to change something. I did it from here. I wanted to resize them. I can do that. I wanted to change the IP. I can resize that. That is where Terraform is needed. Like if I go onto the portal, I have to create the resource group. I have to delete that. I don't know which name was there, what kind of resource was there, and what are the policies are already applied, what are the NSG ports were opened. So that's why I have this main file written. And in that main file, I destroyed that because I wanted to resize that VM, or I wanted to change that VM structure. So I destroyed that. And after that, I'll recreate that and host my application via the Ansible or via the AKS cluster that way. Okay. And I can create a PowerShell script as well that I'll be going to show you. A PowerShell script is going to create automatically small application. It will going to download Apache server in Linux VM, and it will start creating that. So let's move with the destroy. Destroy is still in progress, and you can see the logs. It is still destroying. Destroying takes longer than the time which is taken by the basically the creation. Okay, that's good enough. That's we have deleted those. Basically, destroy and destroy is equal to delete. So let's look forward. We right now we are seeing that. Let's refresh. Gone. Correct. So that's flow. Initializing the plan, then creating the plan, then applying the plan, and then destroying that particular plan of the creation. Whatever services which is created, that we have to destroy. Clear? So this is what like labs are going to be start. But we have already done the lab. This lab we have already done. And along with that, there are certain changes, certain pointers which we are going to discuss. That is why the course curriculum is very long. Okay. So if you are seeing how capable Terraform is, you have to ask this question after we complete the day 3. Okay. So that we get to know how it is communicating, we get to know how it is building, how it is destroying, that all things we are going to get to know. Okay. Now we are moving with the another part, which is workflow. I'll be covering small slides on that. This is the topic we are going to complete, and then we'll see HashiCorp configuration language, which is basically we already seen, but how you can write your own code. We have copy pasted those code right now, but we need to know that how we can write those code so that we can configure as per the requirements are coming in. We can configure the codes. Clear? Okay. First of all, let me show you the codes. I'll not be showing you the guides first. Let me show you the codes, and that code we are going to use. These are the labs which you are going to do. Basically, we have to create public IP. This is already having the code. You see, in that we used just an example. I wanted to say we have here what we did. We already did AZ login. Okay, we did AZ login, but in this case, right now we are not going to get the secrets, or if we are admin, we need to get the encrypted secrets, and from there itself we have to write the information, and that's where we don't need to write AZ login. Okay, and similarly, what it is doing, it is going to create some local, and then it is importing the already created subnet. It is data means that is importing the data, or already created subnets is there, and after that resource. By these keywords you can understand provider, that means the providers, like the which cloud service provider you are going to use. Along with that, data is basically already created something and you wanted to fetch that, and resource is basically resource which is going to be created, new resource which going to be created. Then again, the network, the virtual network is going to be created. This is the app network, local network, and the location you are fetching from here, and you have defined this variable, and that's too easy to understand, and that we are going to look again and again these files. So let's not save it, and these are the files. And if your team says you have to set the alerts, you just copy the code, you understand where you have to do, you have to write the code, and this is the logic of the setting alerts, and what kind of alert you wanted to set, that you have to look for. Okay, so the name, send to admin, where you are going to send the alerts. What kind of alert it is asking? First we have created a action group. In alert, first we need to have the action group, and then what kind of action we are going to have, that we need to write on. So in that, this is the action. We are going to write a monthly budget. In that particular, amount should be 50, and time grain should be monthly, time period should be starting date from this and this. And after that, like for an year, basically a month, like 12 mails will be shoot out to me as per the requirements. The notification is enabled true. Threshold should be 70%. If your threshold is 70%, you have to send me a mail. Okay, so this kind of information, from where you can get whatever form you are filling here, whatever details you are filling here. If you are creating any resource, you are creating any app service, the form which you are creating here, that details you have to fill in into the Terraform itself. So these details you have to give. Terraform reason equal to central US, operating system is equal to Linux, such things you have to give. Okay, so that is what it is. And then action group is created. Action group, we have to give the mail ID as well. So we have to give the mail ID, and I have to add my mail ID. This is my mail ID and I have to add that so that I'll be getting a mail from now onwards. And this is going to be a logged, like this is where I'll be getting information, and my team managers and everybody will going to review this code. In terms of PR generation, I'll be connecting this to the GitHub or to the remote registry, and from there itself I'll be getting emails and all. Great. Okay, let's not save this, and let's move on to the module number 5 for now. Then we'll move on to the module number 3. Again, module number 5, few slides which we already discussed, you guys already know, but I wanted to cover it. And this is very important in terms of exam perspective. Whatever is going to be coming in the exam, that is very important. That's why I've mentioned this screenshot, like navigate the Terraform workflow, write, plan, create, then initiate, validate, Terraform plan and apply. So in that particular command, let me type another command, Terraform, like I wanted to create the same resource group and the same data I wanted to create again. I will be Terraform init, typing this. Okay, that's clear. Okay, here I'm adding one more command. Till now, I have added Terraform init, after the Terraform plan, then Terraform apply. After that, I added Terraform destroy. Okay, now I'm adding one more command. Terraform init we did. Terraform plan I am going to do. Okay, I've read the wrong command. Terraform plan, clear. Terraform plan. Our code is logged. Everything is logged in this state right now. Now it will showing what it is going to do. Let's do one more command. Terraform validate. Is this template is valid or not? It will say it's valid. Let me make a mistake. Okay, I have removed this and let's save it. It is going to throw an error. Where it is throwing, got to know that. Understood. Terraform valid, invalid multi-line string. This is the string. This is invalid. Again, multiple times it's giving an error in this line. That's where like Terraform Validate is going to help you to resolve the queries. Syntax errors are going to be help. Okay, so again, let's type it. I want to save this. Let's save this. Let's validate. It will show you success. You can make a note Terraform init. Another note is Terraform plan. Another is Terraform validate. Another one is Terraform apply. And fifth number is Terraform destroy. Now let's apply the plan. It's valid, then let's apply. It is going to create, and you guys know what it is going to do. Okay, so workflow of the Terraform is very important in terms of writing code, after that previewing the changes, and then creating the infrastructure after the applying the code, what I've shown you. Okay, this is very important. Again, like how it is going to create. So first of all, it will define your infrastructure. So in this part, we are going to talk about Terraform workflow, where the writing codes, and start with the writing codes, and then preview changes up before applying, and then provisioning your infrastructure, which is basically the end goal of your designing. In that particular, there is one more term which is coming in, validate. We have seen that. So basically, first, this is the core of our workflow. In this formation, there are 3 aspects which we are going to talk. First is writing the code, then initializing the code, then plan the code, and then apply the code, and then destroy the code. That I have already talked. In that particular, we have to add the validate as well. And we know how it will going to work. First, second, third, and okay, and this is the basically we are going to look into these components. We haven't touched variables.tf and the .tf var that we are going to talk. So how to write basically a Terraform file? Basically, Terraform file is based on 2 things. The structure is basically like the name, then the provider name and the details which you are going to do, and then local name, and then the double quotes. This is the syntax basically. After that, key value pair, key equal to value would be in double quotes, and then that's close. This is the how Terraform works. And like the name could be provider, resource, or data. Provider basically to define cloud. Resource would be for which kind of resource you wanted to create, and data is already created resources. Understood? And then local name is basically in which name Terraform know the code. Like in this name, like if you create an example, or we were doing RG creation, and that is the basically going to create. And in this key value, this is the basically what kind of resource you wanted to create. Name, you have to give the name. After that, exact name of the resource group, like right. So this is a demo of which is a log file basically. So why we use this log file? It is basically generated automatically. Focus on the provider, simplifies managing Terraform automations. This is basically simplifies your automation, and it is introduced in Terraform 14. Basically, we are using multiple versions. and there are a lot of versions available on the Terraform, and currently this is the latest version which is introduced in the market. So Terraform 14, similar to the Windows 11, and it is kind of that version which we are referring. So that is introduced by the HashiCorp in this last year itself, and generated automatically when init is run. So once you Terraform run it in it will automatically generate your this particular log file. We already seen that this is a log file, and along with that there is another tf.state.log file is also going to be generated. So we have already seen those. So those two files will be helping. And suppose there is another version came in, you wanted to change to that version. What you have to do, you have to type Terraform init upgrade. Let's do that as well. Terraform, but right now we are already in the latest version. Terraform, right now init won't work because we have to remove that script first. That Terraform script which we were using for the backend one. So let's save it. Okay, then Terraform init and then upgrade. Okay, they have changed the command. Okay, yeah. So it is says that Terraform has been initialized and it is already using the latest one, and the Azure ARM, which is also a latest one. They have fetched that, and we are already using the latest one plugins already. So not an issue for us. We are just moving with the slowly with the process which is required to understand. One more topic which is very important. We are going to cover that. So we have already discussed how it is introduced, how it should be written, and the versions and everything. So that we are not going to discuss again. And then syntax, this is the blocks we need to look forward. So basically HashiCorp configuration language is written in two formations: key equal to value. Whatever key you wanted to have, that should be equal to your values, or by values could be string, could be numbers, could be integer, basically numbers, could be float, or could be a boolean, false and true false formation. Okay, so that's basically we have already done this. We have seen this. This is basically the number and the value which is key. This is the subscription ID and this is the value. Subscription ID or name, and this is the value which we have given. Name, location equal to East US. So that's a process of having HCL language coding. HCL language coding is only in this formation. It will automatically fetch this code, and along with that configuration syntax we can look for. Let's go into this particular one. If you are working with the Terraform, and there's some scenarios which we are going to introduce in later classes, that's where this link is going to help a lot. Let's go into the browser, and configuration syntax, basically image ID is equal to the arguments in the blocks which we are filling. So blocks are basically like the double quotes or double brackets which we are using right now. This is just information in the key value pair syntax. This is an argument, but if you write in the blocks or particular brackets, this is a features which is written in the inside that I can define multiple features which is defined by the Azure, so that I can help with my configurations. Okay, and it is automatically generated. If you see this, I'm writing this and I have entered. I haven't given the information of the resource group. I'll type the location equal to West East US. So this is basically just a key value. Clear? Okay. So please have a bookmark on these notes. And this is basically the file which is the URL I have shared. In that, this is for the AWS, and we have upcoming in the slide we have for the Azure as well. And we have seen this. We have understood how this configuration will going to talk to the other providers. And this is what declarative is. That like we know declarative, and we have seen the imperative and declarative two ways. So this is what declarative. You just need to define what you want. You just write informations again and again, and that is going to be incoming in desired state for your configurations. And one file which is a plugin, which is we already seen. I have explained this. We have a lot more content. We have covered everything, like which is it is written in the slide. This is basically is for your help in the future, but I have explained everything we have covered. We have just didn't cover these two topics, define and initialize. So that we are going to cover now, and we have a small time period where we are going to complete this. And then plugins, we have installed this plugin basically are Azure RM, which is already there. Provider, which we could have a provider, or we can create a main.tf. We know that we can have a main.tf, or we can separate like vm.tf is there, and then virtual network.tf is there. I can create those as well. And the variables to initialize, that we are going to see. And then state file, we have been discussing from in the beginning. What is a state file? It is just holding your state of your configurations for the further release. And it could be written in two formation. Start building the codes. Syntax we know. These are the basically for the Azure. This is the Azure one. And if you wanted to have the subscription ID, until unless you don't use AZ login, you can have the similar way. And how you can find it, we are going to look into that as well. And the versions and provider blocks, best practices to pass it during the runtime itself or define it into the environment variables. So basically, why they are saying it, basically what it is, versions of your applications, and that should be defined in the runtime itself. Once you have started your Terraform plan, that should be started building into itself. Once you click on the Terraform plan, there it should ask for the which kind of version you wanted to use for the provider block. And this is basically a best practice, and best practices are a lot of the best practices we have to follow in the Terraform that we are going to discuss. And the authentication, we know how to do the Azure CLI authentications. We already seen that Azure CLI, everything we did. And the authentication we did with the subscription ID, that subscription ID we can provide. And that's where we have seen one error that we have resolved. And across tenants, suppose you have multiple tenants. Right now, let me show you in my Azure. Okay, Azure Active Directory, tenants, properties, not the tenant, not this, Azure Active Directory. I have multiple directories. These are the directories I have. So I have to, suppose in your in our organization right now, this is my default one, which is I'm just using this one. And I can define which is my favorite one. I have wanted to use this, I wanted to use this, I can define that. Okay, so this is the one which is very favorite to me, because this is my local one and default one. And I have to copy this organization ID, and let's put it into the particularly this document itself, in this particular tenants, if you wanted to create for the provider information. So that's where you can define everything. And along with that, we have resource blocks. We have seen that. And resource blocks are basically this is the resource block. This is your actual name of the resource, Azure RM resource group. I wanted to create an Azure RM resource group, and this is my local name. Like Terraform is not going to know your resource group is created by this name, but Terraform knows that RG is something which is created and locally introduced. Okay, so that is basically the definition itself. It defines resources are the most common important code blocks in the Terraform language. And by defining a resource, let's come into the fourth line. These are already we already know the attributes and resources. By defining a resource code block in the configuration file, you are letting Terraform know which infrastructure object you are planning to create. Okay, so how Terraform is going to get to know like which kind of infrastructure I will be going to create. So that's where I have to tell him like Azure RM resource group, this is the information that he should know, or Terraform tool should know, that I am going to create a resource group, I'm going to create a load balancer, I'm going to create a multiple tools along with the resource and resource and resource. So this is the formation that we know, and this is again a basic structure of that. And this is what we have seen, and the arguments and the required and optional arguments. So you see, you cannot create a resource group without giving an location, right? You cannot have it, because you go onto the portal. And why Azure is intelligent, that they are already saying you cannot create this. You see, this is the red sign. This is the required one, and this is the red sign. That means you have to have the services resource group. You need to give the subscriptions, and subscriptions we are defining in the top in the Terraform files, but we need to give the reason which is known as location in the Terraform, so that we have to provide those information itself. Clear? These are very basic and everything is clear. And I wanted to have one more point, like these are already covered. Okay, now let's come on to the real picture, where Now this is a main.tf. We have worked till now. We have worked with the main.tf. Now there is another variables.tf and terraform.tf where and output.tf. So what are all these? We have to look into that. Okay. And first of all, main.tf is basically going to contain the information which you wanted to create. And from there itself, we have to fetch the variable locations, and those variable locations going to give you the details. Like basically this variables location is basically, you can say, a building blocks. Basically these are the blocks. Every information is a block, location is a block, and your admin username is also a block, and admin password is also a block, and that is need to define. Like it should be string, it should be a number, you have to define that. Okay. And then this variable.tf is associated with terraform.tf where. So this is connected with that. If you are creating a variables.tf, you have to have the terraform.tf vars, right? So let me create that variable.tf and then terraform.tf vars. Understood? So what are we going to do in these files that we are going to look forward now? And some of the changes we have to do in this main file as well, so that we don't provide the information. We are just not going to give the information. We are defining our information in this. Like first of all, we are going to have a var, which is basically going to give you the details. Variable we are going to define, and that is basically coming in the double quotes and then location, and then that's it. This is our block. We have created this. This is right now in terms of a type, you can equal to give string. Clear? And now this is what I've defined: variable and then double quotes and location. Clear? Basically this is written as a variable itself, and variable itself, and here you have to define which variable in variable equal to what. Like right now here in this we haven't given any value, location, and this is all hidden, and in this we have to write all those things. Location equal to east US, and it is not required any syntax. This var file is just fetched by this, like directly variable. If you have defined a variable location or any kind of variable name, it will go to the tf var, and in that tf var it is automatically fetched that it is the location and this is the value. Okay, so this is what it is going to define. And in this, how you are going to do that? In the location, we have just to change the location. We have to fetch that variable now, and let's go into the tf state, into that variable file, and in that we have to define this var dot location. Automatically it gives, this is the you have created already, this is the one you have created, and again I can use it here as well, var dot location. So that is like, if I wanted to create to another location, let's do it for the another location. I have to define another variable location 2, and okay, so in that location type should be string, and that's here I have to give the value of location 2 equal to West US. Clear? And now I have to use location. It will say 1 and 2. You wanted to choose 2. Another one is, I don't wanted to give names here. I wanted to create a variable for the names so that my values are fetched from the variable files itself. And what this flexibility is, let me give you that flexibility as well. Let me create another variable resource group name. Like this tool is now becoming intelligent because we have defined already in the above one, like what we are trying to do with this file. So they know this is a variable file because we have installed those plugins in the Terraform or HashiCorp or Azure plugins. That's why this tool is knowing that I know what you wanted to look for. So I'm going to define the Azure RM resource group detail, first resource group. Okay, then should be type equal to, and then it's also going to be string. Basically the resource group name is going to be in string, and you can add the descriptions as well. And this is for the testing. Understood? This is for the testing. That's it. And how I going to use this particular resource group? I have to define the resource group name first. What variable name I have given, that I have to define here. Azure RM resource group equal to 1, Intellipaat, that's it, Intellipaat 2. Clear? Let's save all these files. Let's use that particular variable here, var dot location or what, Azure RM, this is the variable name. Okay, clear? Now we are good to go to release our code. I haven't created, I have just shown you the multiple arguments and multiple changes, and then another file. So why is it so useful? Because you don't need to deal with your Terraform main file. What you do, you wanted to create another environment in another location, you deal with this tf-var file. Like Terraform var file, I wanted to create another resource group, or I wanted to change the resource group name, and this should be the different name, and I just create my file. Again, I'm just using the same template. I'm just dealing with these var files, what I wanted to create. This is applied for the load balancer. This is applied for the AKS cluster. This is applied for every kind of resource. Why we have choose resource group? This is basically so you guys can relate to basic concept. So we can create 100 line of code in now. Okay. So that let's create this. Let's see if it's work or not. But first of all, if you see these are the white dots because these are not saved yet. Save, Control S, and then Control S. Now Terraform init. There is some mistake we did earlier. Required t constraint string. Okay. So strings does not require double quotes. Okay. If it's a string, it should not be using double quotes. We are going to look for the data types as well. But this is what the method is, like how you are going to deal with and there are a lot more concepts also available. So yeah, let's do it. Initialize. It is going to initialize now. Yeah, that's done. Then let's type Terraform plan. Let's clear this first. It's going to generate any issues are there or anything is there. It is going to generate those information for us, or it is going to tell us you are going to create 2 resource groups. So yeah, it is telling us Intellipaat resource group 23 and then Terraform role check it's going to be created. So yeah, okay, let's create it. Terraform validate we can use as well to validate our template. It's working or not. It's working. Terraform is going to validate our template and then apply. There is one more way. Terraform plan -out main dot plan. Let's create a file. Like you see, you look into that, it will going to create a file. Created. That is created. You see, this is the plan that is created. Like this file is not readable because this is encoded, and this is the plan of our everything what we are trying to do. Let's run this plan. Terraform. It will automatically give you this command. You can use this by that way. It will going to run that. Terraform apply main plan. So till now we know how this variable is going to work, and let's look into the slides. You guys already I have explained this. So let's clear it up and let's close the session now. So that's what we are going to do. The parameterization we did, and input variables, like basically you can define any name of the variable, and that is all dynamic. Scripts are more dynamic. And now let's play with that script. Now I don't want to define anything. I wanted to have a South India. Let's create South India. Reason I wanted to India and another location, West US 3. West US 3, I think it's East US 2 is there. East US 2 is there. Like, and now Intellipaat is not here. I'll be creating with the name of doctor. Okay, this is the resource group of the doctor, and now I will be updating this with my plan as well. So why I just don't need to mess up with my these main configurations. I just typed here and I'll be creating another infrastructure available for me. Okay, so I hope you understand the goal of variables, and it is going to work similar way. So we have defined this, we have done this. We are going to do it in the morning. First off, we are going to do 5 labs, which is based on the VNets, which is based on the clusterization, which is based on subnets and all. So that's where we are going to write the code and all. But this is what the procedure we are going to follow. So variable OS you wanted to define, you have to give the OS image. Description you can give. After that, type what is the OS image I wanted to install. Ubuntu I can install. That definition I will be giving. And then variable blocks we already seen. Initializing the variables. So how initialization works. So TF-VARs, you just leave that JSON file because TF-VAR we are going to use auto TF-VARs, and we can have a variable flag. So this thing, what you can do is you can define a variable in the command line. Once you are applying your code, you can define there itself. You see, if you haven't created a TF-VAR, it will ask in the live location like what kind of TF you wanted to use. Let me show you that. Okay, let's close this. I don't want to give any details in this. Okay, and let's save it. Let's delete this file, and I have some variables. Now it will be going to ask me at the runtime. here itself, clear, and then Terraform init. After that, let's clear again, and then Terraform plan. It is asking the values first. This is for testing, so I'll be giving Manish resource group another value. It is asking for the location of another resource group, location East US, and now it is starting creating a plan. So you understand this. Runtime you can give while you're working, or you can give with the command as well. So that is also I'll be going to show you. Okay, so we are not doing that. We are not running up apply command, but we can do with this where just a second, and then okay, basically the command, if I have to find that small command, -var, yeah, then after that -var equal to location you can define here itself, like your which variable for you are defining in. Okay, so you are doing it for the location for now, -var, and then flag what I can say the location equal to East US. Such kind of information you can provide, and then location 2 again -var you do it, and location 2 equal to East US again. So such kind of information you can provide with this command line. Okay, and this is what we have done. We have seen the command line, we have seen the environment variables, we have seen the tfvar, and auto tf we are going to cover tomorrow, and the flags we have seen. So yeah, South India, this is what I was referring to. So this is the command. So double quotes you have to put in, and equal to you can define your variables. So that's all we have to do the change here. So just double quotes because it's a string, and then just double quotes, but it's still, it will ask for a resource group name as well. Let's type in, and it will ask for the resource group name as well. Yeah, resource group something something something, then it will create a command. Previously it was asked with the location, with the location 2, and then we have given the normal value of the resource group, and that is going to work. Clear? It is kind of a overriding your variables. Okay, let's close this now, and let's have a great day. Basically we have completed all the topics which were required to complete. And
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.